Hey, look at this blazing monster. It's a white dwarf. These stars are known for gobbling up passing objects, and one day, these objects might be the planets of our own solar system. According to a new study, parts of the solar system will be pulled into a white dwarf star, crushed up, and eventually ground into a fine dust like coffee beans in a blade grinder. Hey, you like that analogy? Now, white dwarfs are a final stage of a star's life. It's a small but very dense star that's typically the size of a planet, the result of a low-mass star exhausting all the nuclear fuel in its center and losing its outer layers as a planetary nebula. When our sun turns into a white dwarf, and it is bound to happen sometime, it'll destroy the asteroids and moons around Mars and Jupiter. They will be pulverized by its gravity. Earth, though, will be swallowed up even before the sun turns into a white dwarf. But it won't happen for another 6 billion years. Researchers working on this topic have come to such conclusions by observing what happened to space bodies, asteroids, moons, and planets that were passing close to 3 white dwarfs. For 17 years, they observed and analyzed transits. That's when the brightness of a white dwarf dips because of an object in a stable orbit passing in front of it. In the case of white dwarfs, we can predict such transits and use them to study the stars themselves and celestial objects passing by them. So, when something gets too close to a white dwarf star, the star's immense gravity rips it into smaller and smaller pieces of debris. The team also found out that transits of such debris are chaotic. Plus, this debris is oddly shaped, which means that it is being devoured further. The first white dwarf used for studying the transit process, this here guy, seems steady and well-behaved over the last few years. Well, until scientists found some evidence of a massive catastrophic event that occurred in 2010 or so. The next star dims irregularly every couple of months before brightening again. And the third dwarf star used to behave close to theoretical predictions. It had transits that varied in number, shapes, and depths. But the latest study has shown that the transits are now completely gone. And this indicates the unpredicted nature of transits. One minute you see them, the next, poof. The reason might be the chaotic environment they have to exist in. As for our own solar system, and our planet in general, its fate looks pretty sad. Earth will be swallowed by the expanding sun, even before our star turns into a white dwarf. As for the rest of the solar system, located further from the sun, some of the asteroids between Mars and Jupiter, as well as some of Jupiter's moons, will be destroyed later. Oh well, they're likely to get dislodged and travel too close to the white dwarf. Now, at the same time, astronomers aren't 100% sure that it's exactly what will happen with our solar system. So I guess we'll just have to wait and see, for like 6 billion years. Speaking of white dwarfs, scientists have recently found one that has a bizarre metallic scar on its surface. This blemish could have formed after the star ripped up and ate a tiny planet orbiting it. White dwarfs with traces of metal in their atmospheres aren't rare. These traces are left by planets falling into stars, affected by their gravity. Experts have long thought that such metal should be distributed evenly across the surface of such polluted white dwarfs. But a new study has discovered a white dwarf with a weird concentrated patch of metal. This star was monitored over a period of 2 months with the help of the Very Large Telescope in Chile. The researchers found an opaque patch of metal. It was located over one of the star's magnetic poles and blocked some of the star's light as it rotated. Based on this position, astronomers concluded that the material could have been funneled into the star by its powerful magnetic field. This process is similar to one causing auroras on Earth, where charged particles follow the magnetic field to the surface. Now, the planet destroyed by the white dwarf was most likely very small, around the same size as asteroid Vesta in our solar system, which is a mere 326 miles across. Its debris is now prominently displayed on the host star's surface. It makes it easier for researchers to examine what the planet's geochemistry was before it was devoured. Such a study might even turn out to be one of the best ways to observe small worlds beyond the solar system, even if such a world has already met its demise. There might be many more scarred stars like this one. The one in question was the first, but probably not the last. Even better, astronomers have already discovered 2 white dwarfs that seem to have similar scars. Making repeat observations of such stars might help us unearth, pardon the pun, no, I meant to do that, unearth even more secrets and make more discoveries. Another bizarre white dwarf discovered not long ago seems to have stopped cooling due to the formation of internal crystals. It challenges existing theories on star aging and also questions the method of stellar age estimation. But scientists might have understood why it may be happening. White dwarfs are believed to be dead stars. They keep cooling down over time, and normally this process can't be reversed or paused. But in 2019, the European Space Agency's Gaia satellite discovered a number of white dwarf stars that had stopped cooling for more than 8 billion years. It might mean that some white dwarfs can generate a lot of extra energy, which is at odds with the classical dead star theory. At first, astronomers couldn't figure out how it might happen. But in the end, more than 97% of stars in the Milky Way galaxy turn into white dwarfs. Astronomers have long thought that such stars are at the end of their lives. After depleting their nuclear energy source, they stop producing heat and cool down. Eventually, the dense plasma in their insides freezes into a solid state and the star solidifies from inside out. The whole process can take billions of years. But the new research claims that in some white dwarfs, this dense plasma doesn't simply freeze. Instead, its solid crystals forming upon freezing become less dense than the liquid and start floating around. They displace the heavier liquid downward. The movement of heavier material toward the center of a white dwarf releases gravitational energy, and this energy is enough to interrupt the star's cooling process and halt it for billions of years. Now, this explanation actually matches all of the properties of the unusual white dwarf population. But this is the first time such a transport mechanism has been seen in any type of star, and that's incredibly exciting. A totally new astrophysical phenomenon. But why does it happen in some stars but not in others? It most likely depends on the composition of the star. You see, some white dwarf stars are formed by the merger of 2 different stars. When they collide and form a white dwarf, it changes the composition of the star, which allows the formation of floating crystals. So this discovery might mean that astronomers will have to review the ways they use to determine the age of stars. At the moment, white dwarfs are often used as age indicators. The cooler a white dwarf is, the older it's believed to be. But now, we already know about possible delays in the cooling process of some dwarfs. It makes the popular age determination method more unreliable. Some stars of a given temperature may be billions of years older than we previously thought. The recently uncovered transport mechanism within white dwarfs means that some of these stars can be shining as bright as normal for billions of years. This complicates age dating and the use of white dwarfs to reconstruct the formation of our galaxy. Hey, stay tuned.
Chebyshev star was discovered in the 1960s. Since then, astronomers have been intrigued by its unique chemical makeup. The star is suspected to contain ultra-rare elements, verging on the almost impossible. Using special equipment on the European Southern Observatory's telescope in Chile, researchers took readings of the star's magnetic field. They discovered that the star's rotation period, which is the time it takes to finish one revolution on its axis, stretches out over almost 200 years, which is super slow. Of course, there are even more bizarre objects called apstars. They're a chemically interesting category of stars that rotate extremely slowly, with one rotation taking up to 1,000 years. What makes these stars even more peculiar is a wide range of chemical elements astronomers detect when analyzing their stellar spectrums. But if we look at Chebyshev star, we'll see that it's both similar to and different from other apstars. It contains unusually low amounts of iron and nickel. Our Sun has 10 times more and incredibly high amounts of rare, heavy elements. Those might include strontium, cesium, and neodymium, as well as at least 2 undiscovered elements. They wouldn't occur through any natural processes we currently understand. There's a hypothesis that the presence of such heavy elements could be caused by a star's unseen companion, like a neutron star. Some people go as far as to say that such an incredible chemical makeup could be a sign of an alien techno-signature. Any specialist will tell you that it's the strangest stellar spectrum they've ever observed. Some even claim that there are so many chemical indicator lines you can't immediately understand what you're looking at while observing the star's spectrum. Chebysky's star also contains high levels of radioactive elements that take a few thousand years to decay. And here's where another mystery lies. They should have long vanished from the star. After all, it's almost 1.5 billion years old. Scientists haven't managed to figure out the reason for the presence of these elements yet. Maybe it's the combination of the star's rare qualities. It spins very slowly, it's hot, and it has a strong magnetic field. This could raise to the surface atoms that would normally be mixed inside the star. There's another theory that explains the presence of these radioactive elements. They could be there as if they were themselves decayed forms of ultra-heavy elements that we haven't discovered yet. So far, no one has been able to prove this theory. Even the discovery of Chebysky's star's super slow rotation doesn't bring us closer to the answer. It's obvious that there's a lot to learn about the bizarre star, and who knows which secret it still has up its sleeve. Another not less mysterious star is called Tabby's star. It's a sun-like orb around 1,500 light-years away from Earth, sitting in Cygnus the Swan. Unlike our Sun, this star dims randomly by 5 to 22%, and it lasts for days at a time. The reason could be a giant planet passing in front of the star, but then the eclipses would be more regular and not so random. And if it was a Jupiter-sized planet, it would also need to block around 1% of the star's light, which would make it unique and unlike anything we know. After American astronomer Tabitha Boyajian discovered the star's massive and irregular fluctuations in 2015, further observations followed. They show that the overall magnitude of the star has been gradually dimming over the years. Some theories trying to explain this phenomenon are quite believable. For example, some scientists think that these brightness changes are intrinsic to the star. They could be caused by its magnetism or changes in heat flow in its interior. Other ideas are more daring, including some kinds of activity of an extraterrestrial civilization. One of the most plausible theories, though, is that the dimming is caused by the chunks of an orphaned exomoon. It could have been pulled away from its parent planet by gravitational interactions with Tabby's star. As the moon approached the star, it exploded, sending dust clouds into stellar orbit. These countless chunks of rock and dust are now moving between Tabby's star and Earth in a giant, clumpy cloud. It could indeed explain why we observe such irregular brightness variations. Usually, when astronomers spot a spiral arm structure, it turns out to be a galaxy. But not in this case. SAO 206462, located 460 light-years away from our home planet, is a young star. It's surrounded by a circular disk of gas and clearly defined spiral arms. The bizarre star was spotted during an exoplanet search with the help of the Subaru telescope located in Hawaii. Instead of finding fully fledged planets around a young star, astronomers discovered planets that were still in formation. These baby planets are growing out of the disk of gas and dust surrounding the star. The disk extends out to around 80 astronomical units, which is twice the orbit of Pluto. At least 2 of these planets have stretched the disk into its extremely unusual spiral shape. A different planet is responsible for each arm. In our home galaxy, there's a giant star that is a real stellar wind machine. At the moment, this monster is just waiting to burst and send a wave of radiation and hot gas towards Earth. All because it's a Wolf Rayet, a star which is at that precarious point before it goes supernova. Its core doesn't have any more helium left to burn. Instead, the star is forced to churn through much heavier elements, for example, oxygen. Unfortunately, it disrupts the careful balance between gravity and fusion, leading to the star shedding its layers. When the oxygen eventually runs out, the star will go supernova, but this time the show will be different. The thing is, WR104 is 1/2 of a binary pair, which means that two stars are feeding into each other, spinning up their stellar winds. It will continue until they start going incredibly fast. Is the potential explosion going to harm Earth? On the one hand, we're far away enough for even a directed supernova to not hurt our planet. At the same time, there's a threat of an extremely dangerous gamma ray burst. Luckily for us, it takes a very specific and unlikely train of events for a Wolf Rayet to produce a gamma ray burst. Plus, even if it does, the star might be pointed far away enough for the danger to miss us. Anyway, astronomers are still watching the star, just in case. A star sitting in the constellation of Centaurus keeps a secret not many know about. At first glance, it looks like a dim white dwarf, but when astronomers analyzed it, it turns out to be incredibly dense. Take the mass of the Sun and cram it into something that is only a third the diameter of Earth. This space wonder is also rather cool. Its core temperature is a mere 11,900 degrees Fahrenheit. For comparison, the Sun's core temperature is around 27 million degrees Fahrenheit. At such low temperatures, stars begin to vibrate, and then scientists can use these vibrations to sneak a peek inside a star. And in the case with the star in question, which was later named Lucy, they discovered that its carbon core had crystallized. In other words, it formed a giant diamond 10 billion trillion carats in size. Since the discovery of Lucy, a few other crystallized stars have been spotted. Some of them have diamond hearts the size of our planet. The last bizarre star for today is called Vega, and it's squashed. The star's bulging waistline is caused by an extremely high spin rate. Vega rotates once every 12.5 hours. This pushes the material around its equator outward. It also leads to the phenomenon known as gravity darkening, when stellar material further from the center of the star experiences less gravity, which makes it cooler and darker. So when Vega faces Earth pole end on, it looks perfectly round. But the dark halo around its middle is a telltale sign of Vega's oblate shape. Most of those twinkling dots scattered across the night sky seem unreachable, but one of them is Betelgeuse, a star so enormous and nearby that you can see it with the naked eye. To find it, locate the first 3 big dots in the Orion's belt. A reddish star to the left is Betelgeuse. It's one of the brightest stars we can see from Earth, and it's just 640 light-years away, no big deal. Betelgeuse has a blue-white O-type star, which is one of the hottest types to exist. Betelgeuse was scorching hot, reaching temperatures of about 90,000 degrees Fahrenheit. Although that was back in the day, now it's an elderly star and it cooled down to just 5,800 degrees. You know, vacation weather. Blue-white stars are absolutely massive and burn incredibly bright because they have loads of hydrogen fuel. But they have a price to pay for this glory. They burn through their fuel super quickly. As they age, they transform into red giants. This is exactly what happened to Betelgeuse. It burned through its hydrogen and started burning helium instead. This caused its outer layers to puff up like a balloon, turning it into a red supergiant and making it one of the largest stars out there. Now it's stretching over 700 million miles in diameter. Now it's about 1,000 times bigger than our Sun. If Betelgeuse replaced it, it would swallow up Mercury, Venus, Earth, Mars, even Jupiter. And its atmosphere would almost reach Saturn. But something strange has been going on. Betelgeuse spinning way faster than it should for a star of its size. Huge stars like Betelgeuse are expected to rotate slowly, but it suddenly started spinning at a rate of about 3 miles per second. Thanks to powerful radio telescopes, Betelgeuse's orange-red surface can be seen in detail. That's how we learned that it often changes its brightness. Sometimes Betelgeuse shines super brightly and then gets very dim. This happens about every 400 days. And recently, a telescope called ALMA, which is made up of many antennas working together as one, showed that Betelgeuse's surface seems to be moving unevenly. It's like one side is coming towards us while the other is moving away. But all of it might be a trick of light. Betelgeuse isn't as smooth as our sun. Instead, it's super chunky. Its surface is like a boiling cauldron. It's bubbling and churning incredibly fiercely. Imagine giant plumes of hot gas erupting from its core, reaching the surface and then vanishing back inside. And these bubbles are bigger not only than the sun, but Earth's entire orbit around the sun. These bubbles also rise and fall super quickly, even faster than a spacecraft. And maybe this tricks our telescopes into seeing it spin faster than it really does. Some astronomers also think that Betelgeuse could have swallowed up another star, and this gave it a spin boost. But these are all just theories. Things got even more complicated when Betelgeuse dimmed once again, this time in a pretty unexpected way. What's interesting, it was discovered using a weather satellite. A regular telescope had a hard time seeing Betelgeuse clearly because of Earth's atmosphere. So they used a satellite that normally watches Earth's weather, but can also take pictures of space. As we mentioned, it usually brightens and dims about every 400 days. But recently, it suddenly dimmed by 2.5 times more than ever before. This event got the name the Great Dimming. The first theory said that Betelgeuse cooled down and sneezed out a bunch of material, creating a massive dust cloud. This cloud blocked the view of the star, making it look much fainter than usual. They also noticed something strange happening to that dust. It started behaving differently, which might be a sign that something deep inside the star was causing trouble. Betelgeuse's brightening and dimming cycle now happens faster in just 200 days instead of 400. And to add to the mystery, in the spring of 2023, it started shining even brighter than it normally does at its peak. Why is this frightening? Because Betelgeuse might be preparing for its grand finale, and this wouldn't be very good for Earth. We might be on the verge of a supernova. When massive stars like Betelgeuse run out of fuel in their cores, they start burning different elements like carbon, oxygen, and silicon. Eventually, they end up with iron in their cores. At that moment, everything changes. Adding helium to iron doesn't produce energy like other reactions do. Instead, it sucks up energy. This causes the star's core to collapse, leading to what's called a core collapse supernova. A spectacular, breathtaking show. Supernovas are so bright that they can outshine entire galaxies. But a Betelgeuse supernova would be special. Because it's relatively close to us, it would be so bright that we could see it even during the day. When it happens, Betelgeuse will shine as brightly as a full moon, but all that light will be concentrated in one point. For about 2 months, it will be so bright that you could read a book just from the light of the supernova, even if you turned off all the city lights and had a clear sky. The idea of witnessing Betelgeuse explode as a supernova is truly thrilling. After all, the last time a star went supernova in our galaxy was way back in the time of Johannes Kepler, more than 4 centuries ago. That event, known as the SN 1604 or Kepler supernova, dazzled the sky for weeks. But don't get too excited yet. We're not sure when exactly it'll happen. One study says that the star might be in its carbon-burning phase. If we're near the end of that stage, then Betelgeuse might blow up very soon, during the next tens of years. But it's nearly impossible to determine because during that last phase, the star barely changes at all. Even though Betelgeuse is close enough for us to study its surface, we can't peek inside its core to see what's really happening with it. We might as well be at the beginning of the carbon-burning phase, and in that case, we might have to wait 1,000 more years before that cool supernova. Another study says that Betelgeuse might have less than 300 years of fuel left in its core. They say that Betelgeuse is known to expand and contract regularly, and its pulsation pattern hints that Betelgeuse is much larger than we previously thought. This would suggest that the star is further along in its life cycle and closer to going supernova. Other guesses come from observations of similar stars. For example, a star called VYCMA in our galaxy is thought to be closer to going supernova than Betelgeuse, and it's been dimming steadily over the past century, unlike the relatively stable Betelgeuse. If Betelgeuse was about to go supernova, it would dim steadily and very quickly. Also, historical records suggest that about 2,000 years ago, people saw Betelgeuse as yellow, not red. If that's the case, then we might be in its early last days after all. In other words, we have no idea whether it will go supernova tomorrow or in 1,000 years. We just gotta wait and see. But let's say it goes supernova tomorrow. What happens to us then? The 1987 supernova in the Large Magellanic Cloud showed that the effects from the supernova might be so strong we can sense it even from very far distances. The Large Magellanic Cloud is almost 170,000 light-years away, and we still detected the radiation. It's kinda hard to say exactly what the danger zone is. A rough estimate could be around 100 light-years. Luckily, Betelgeuse won't pose any danger to humans. It's hundreds of light-years away, and its supernova won't influence us in any way. We'll be able to enjoy its supernova beauty without any harm.
Stargazers, come up here, because I have exciting news. Astronomers have just completed the full mapping of 2 pairs of stars outside our Milky Way galaxy that are chowing down on their stellar neighbors. Not only does it give us a better understanding of stars in general, but it can also help us measure distance in the night sky. Did you know that more than half of the stars in our Milky Way are paired? And while it's unlikely that other galaxies have a significant number of binary stars too, they're usually too faint to see. But these so-called symbiotic stars, where one star consumes the other, are extremely bright and easier to observe. And, according to scientists, measuring the orbits of these symbiotic star systems is an essential step towards learning whether other galaxies create binary stars like those in our Milky Way. Now, let's get down to the nitty-gritty. A pair of stars may be born together, but due to their masses, they age differently. The more massive one burns through its material faster, reaching the end of its lifetime first, and leaves behind a compact white dwarf. White dwarfs are small and dim, but can pack the mass of the Sun into an object the size of Earth. If close enough, their gravity can pull material from their companion, creating a signal that astronomers can identify from far away. Draco C1 and Lin 358 are the symbiotic stars that have been fully mapped. The stars in Draco C1 take roughly 3 Earth years to orbit one another, while Lin 358's components take just over 2. These are the first full orbital measurements of any symbiotic star system outside the Milky Way. The new measurements will help astronomers better understand star formations in other galaxies. In some symbiotic stars, the white dwarf can slurp enough material from its companion that it explodes in a supernova. These supernovae are incredibly bright and can be seen across the universe. They all start out with the same brightness for a nearby observer, making them like a sort of standard candle for measuring the universe. While Draco C1 and Lin 358 are unlikely to explode as supernovae anytime soon, understanding how they work can provide us with a better understanding of how these standard candles evolve. If you're here to complete your knowledge of weird stars in the universe, don't be disappointed. We're not finished just yet. Have you ever wondered about the biggest stars in the universe? Scientists have recently discovered a gigantic star called UY Scuti. This bad boy is located about 9,500 light-years away from Earth and is truly out of this world. It's about 1,700 times larger than our Sun, which means if it were in our solar system, it would reach past Jupiter's orbit. There's more. UY Scuti isn't just massive, it's also super bright. It's what scientists call a red supergiant. and it shines with a brightness of about 340,000 times that of our Sun. If you're thinking about getting a tan from this star, think again though, it's way too far away for that. How does a star like UY Scuti even form, you might wonder? Well, it starts out like any other star. A cloud of gas and dust collapses under its gravity and starts to heat up. Eventually, the temperature becomes hot enough in the core of the cloud to ignite nuclear fusion, and a star is born. But UY Scuti didn't stop there. It kept devouring more and more gas and dust, growing larger and larger. This process continued until it became the giant we know today. As fascinating as UY Scuti is, it's not the only big star out there. There are others, like VY Canis Majoris, which was once thought to be the biggest star until UY Scuti stole the show. VY Canis Majoris is still a force to be reckoned with though. It's about 1,400 times larger than our Sun, and located about 5,000 light-years away from us. But here's the kicker. Stars like UY Scuti and VY Canis Majoris aren't even the biggest things in the universe, not by a long shot. There are objects called hypergiants that make these stars look like ants in comparison. One such hypergiant is Stephenson 218, located about 20,000 light-years away. It's about 2,150 times larger than our Sun, and shines with the brightness of 7 million suns. And just when you thought things couldn't get any crazier, there's a mysterious object called the Great Attractor that's pulling everything in our local group of galaxies towards it. We don't know what it is or what's causing it, but one theory is that it's a massive cluster of hypergiants. We'd be minuscule in comparison. The next star is so metal, it's practically headbanging all the time. Jokes aside, scientists have discovered a star that's called a heavy metal subdwarf. Now that's a band name. It's a type of star that's seriously heavy metal. This star has more metal in its composition than any other star we've seen before. Such stars are said to contain metal elements like iron, nickel, and chromium. This heavy metal subdwarf has about 10,000 times more iron than our Sun. In their discovery, astronomers used a technique called spectroscopy, which involves analyzing the light that comes from the star to determine what elements it's made of. By looking at the spectrum of light, scientists were able to see that this star had an unusual amount of metal in its composition. There's more. This heavy metal subdwarf isn't just a regular star with a lot of metal. It's also really weird in other ways. For one thing, it's smaller and cooler than our Sun. And for another, it's really old. We're talking about a star that's been around for almost as long as the universe itself. What does this all mean? Well, scientists are hoping that by studying this heavy metal subdwarf, they can learn more about the early universe. Since this star is so old that it was around when the universe was just beginning to form, it's seen a lot of stuff. By studying its composition and characteristics, scientists can get a better understanding of what the universe was like in its early days. This next star is one of the coolest things in outer space. Her name is Vega, and it's one of the brightest stars in the night sky. Some recognize it as the shiny point of light in the constellation Lyra. And get this, it's only about 25 light-years away from us, which in astronomical terms is practically next door. Scientists have been studying Vega for a long time, and they've learned some pretty interesting things. For starters, Vega is a young star, only a few 100 million years old. That might sound like a long time, but compared to our Sun, which is around 4.6 billion years old, Vega is practically a newborn. Vega is also a very hot star, with a surface temperature of around 17,000 degrees Fahrenheit. To put that into perspective, the surface of our Sun is only about 10,000 degrees Fahrenheit. So if you think it's hot outside today, just be glad you're not hanging out on Vega. Another interesting thing about this star is that it's surrounded by a disk of dust and gas. This disk is called a debris disk because it's made up of leftover material from when the star formed. Scientists think that this debris disk is similar to the one that surrounded our solar system when it was young. Vega is also a source of cosmic rays. These rays are high-energy particles that zip around space at incredible speeds. They're made up of protons, electrons, and other particles, and scientists aren't exactly sure where they come from. But they do know that Vega is one of the places where cosmic rays originate. But wait, there's more! Vega is also a famous star in pop culture. It's been used in a lot of movies and books as a source of inspiration, mostly because of its brightness and cool features.
In a star system far, far away, to be more precise, 2,600 light-years away, there's an exoplanet called Kepler 1658b. It's a gas giant that resembles our Jupiter. But what differentiates it from Jupiter is that this poor planet is doomed. It's spiraling toward its parent star, which will eventually end in a fiery collision. But the most interesting thing? Astronomers would have remained totally ignorant of this fact if not for a tiny clue. It was a really minuscule change in the planet's orbit. It wouldn't have been noticed if astronomers hadn't compared more than a decade of data received by different telescopes. More precisely, scientists have been watching the exo-Jupiter pass between our planet and its parent star once every 2 weeks for the last 13 years. And they've noticed that the orbit of the planet is getting smaller and smaller. Every year, Kepler 1658b needs 131 milliseconds less to complete a lap around its star. If this tendency continues, the planet is bound to collide with its star in 2.5 million years. Even before this discovery, computer models predicted that some planets could meet their end by crashing into their stars. But this is the first time when astronomers have some real proof of such an outcome by measuring almost imperceptible changes in a planet's orbit. They now know for sure what happens when a planet is going to crash into its star, even though we probably won't be around to witness it. But let me tell you a bit more about the doomed planet. It was discovered by NASA's now retired Kepler Space Telescope. It was launched in 2009, and its mission was to find planets orbiting other stars, aka exoplanets. And the very first exoplanet the telescope spotted was the very gas giant we've been talking about. But it took astronomers about a decade to confirm that this space object was indeed an exoplanet. This world is like a denser version of Jupiter. I mean, take 6 Jupiters worth of material, roll it into a ball about 1.1 times as wide, and voila! The planet is tidally locked to its parent star, which means that it makes one complete turn every time it finishes a lap around the star. As a result, the same side of the gas giant is always facing the star. It's the same as what happens to the moon. Our natural satellite is tidally locked to Earth. That's why we only see half its surface. Now, what is making the exo-Jupiter fall into its star? The same process that is pushing the moon away from Earth. When a moon orbits a planet, or a planet orbits a star, their gravity forces interact and tug on the other's mass. That's what causes tides on Earth. This tugging releases some energy. It can make an object speed up and slow down. In the first case, a space body will move higher. In the second, it will start moving lower. And this is exactly what's happening to the gas giant. Its parent star is 1.5 times the mass of the Sun. So, no wonder its tidal forces are gradually slowing down the planet's movement, making it fall inward. This all sounds kind of tragic, but this potential collision is by far not the weirdest thing happening in space. Let's look at some others. For example, Betelgeuse, a red giant in the Orion constellation, started to dim in 2019. This confused astronomers. By that time, the star had already swollen to enormous proportions. If it was to replace our Sun, its outer surface would spread far beyond Jupiter's orbit. And then Betelgeuse became dimmer in the fall of 2019. This process continued through February 2020. The changes could be seen with the unaided eye. No wonder, the star's brightness had dipped by 2/3. At that time, astronomers were sure Betelgeuse was about to explode into a supernova. They continued to observe the star, but unexpectedly, it returned to its regular brightness. Thanks to the Hubble Space Telescope, scientists figured out that the star had ejected some of its material, and this partially blocked its light. How about cotton candy exoplanets? Those are particular planets outside of our solar system. Also called superpuffs, they have the lowest density ever discovered. This gives them an airy, fluffy appearance. But despite looking like the most popular amusement park treat, such planets are enormous. Come to think of it, scientists often discover strange things in space. Some of them look like blurry blobs. But there's one type of these blobs that doesn't look like any other known space body. The odd radio circles are only visible in radio telescopes. They might be the remains of supernovae, but some astronomers go as far as to claim that they might be the throats of wormholes. Those are hypothetical tunnels between two very distant points in space. The Juno mission noticed something weird in the upper atmosphere of Jupiter. The unusual phenomenon was blue sprites and elves twirling above the planet's surface. These are two kinds of bright flashes of light that appear for short periods of time, mere milliseconds. They extend up and down toward the surface of the planet. On Earth, such flashes usually happen at the height of 60 miles above massive thunderstorms. Rogue planets don't orbit their stars, maybe because they don't have any. These free-floating space bodies travel across the universe and can end up literally anywhere. They're also pretty hard to find. Rogue planets produce only weak emissions, but not so long ago, astronomers spotted the smallest rogue planet in the Milky Way. It's smaller than Earth, but a bit bigger than Mars. Fast radio bursts are blindingly bright bursts of radio waves. They pack as much energy as our sun produces in days, but last mere milliseconds. Most of these fast radio bursts come from far, far beyond the Milky Way. But recently, astronomers have detected some originating in our home galaxy, and their source is a magnetar just 30,000 light-years away from our planet. If it does exist, nuclear pasta is the strongest material in the entire universe. Formed from the leftovers of extinguished stars, this substance gets squeezed into spaghetti-like tangles of material. It can break, but only if you apply 10 billion times the pressure needed to shatter steel. Not so long ago, scientists discovered that one of the most massive stars in the neighborhood had just disappeared. It was a star 75 million light-years away from Earth. Normally, it'd be too far away for astronomers to clearly see individual stars, but only unless they're huge. And the star we're talking about was enormous. It was shining 2.5 million times brighter than the sun. For the last time, astronomers saw the star in 2011. They decided to examine it more closely several years later, but it was already too late. The star had vanished. Such massive stars usually go out in extremely bright supernovae, but astronomers noticed nothing like that in this case. There's a theory that the star collapsed into a black hole without triggering a supernova first. It does occur among stars approaching the end of their lives, but very, very rarely. There are black holes, and there might be mini black holes, even though their existence hasn't been proven yet. Unlike their massive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. Their mass can vary, but just one minuscule thing might have the mass of 1,000 sedans. One theory claims that tons of micro black holes could have been created right after the Big Bang and the beginning of the universe. Some scientists even go as far as to say that a couple of mini black holes pass through our planet every day. More than 7,000 light-years away from Earth, there is the Eagle Nebula, a young cluster of stars just 5.5 million years old. The Hubble Space Telescope managed to take an image of several dark silhouettes near the nebula's center. Those are the so-called pillars of creation, an active star-forming region. Look, how cool is that?
Psst, a giant is hiding in the sky. Kipu is the biggest thing we've ever found in the nearby universe. It's been messing with our understanding of the universe for years. and we've just discovered it. Quipu is dense, powerful, and dangerous to ignore. If we don't understand structures like this, we might be reading the universe completely wrong. So, what exactly is it? It's not a solid object like a planet or a star, and it's not a single thing. It's a superstructure, basically an entire region of the universe, a tangled mess of matter spanning a huge amount of space stitched together by gravity. Quipu is made up of an enormous web of galaxies, galaxy clusters or giant groups of galaxies, gas and dark matter. It's like a superhighway, with galaxy clusters being the cities, filaments being the roads, and dark matter being the invisible infrastructure holding it all together. This giant stretches across 1.3 billion light-years. That means if you traveled at the speed of light, it would still take you 1,003,000,000 years just to cross it. Quipu also holds 200 quadrillion solar masses, even though it only takes up 13% of the observable universe. The name Quipu comes from the Incan system of knotted cords used to record things, called quipus. It was like a writing system. In that system, each knot, color, and twist told a story, numbers, taxes, harvests, and so on. So, when astronomers saw this colossal structure in space, long, tangled, and branching like space cords, they named it after this language of knots. Plus, the shape of the space reminded scientists of those threads. There's a long central filament, and the smaller ones are branching off the sides. What's even more fascinating, Quipu isn't alone. When scientists mapped this part of the universe, they found 5 of these massive structures. They aren't just sitting there either. They formed over billions of years through gravity slowly pulling matter together. All told, all those giants hold nearly half of all the galaxy clusters in that region, 30% of all the galaxies, and a quarter of all the matter in the observable universe. The team that found Quipu used a clever trick. They searched for X-rays coming from galaxy clusters. These clusters aren't just full of galaxies, they're also filled with superhot gas. That gas is so hot it glows in X-ray light, which we can't see with our eyes, but special telescopes can. If there's a lot of that X-ray glow, it means there's a huge amount of matter, galaxies, gas, and dark matter all pulled together by gravity. That's where the densest, most crowded areas of the universe are. So, by following the X-ray glow, the scientists could draw a map showing where the biggest cosmic structures like Quipu were hiding. Why does any of this matter? Because these megastructures mess with everything. First of all, they warp the cosmic microwave background, the ancient light left over from the Big Bang. It's a faint glow of light that fills the entire universe. After the Big Bang happened and our world was created, it emitted its very first light and signals that still haven't completely weakened yet. The leftover radiation is still coming to us, even after 13.8 billion years. By studying this ancient light, scientists can learn what the early universe looked like, and Quipu ruins it for us. These megastructures hold so much gravity that they bend and distort this ancient light as it passes through them. That's called the integrated Sachs-Wolf effect. These warps add noise to the original signal, and now it's harder for us to get a proper, clearer understanding of what the baby universe looked like and how it expanded. They also mess with the Hubble constant. The universe is constantly expanding, and the Hubble constant tells us how fast it's growing. In other words, how quickly galaxies are moving apart from each other. But giant things in space, like Quipu, have so much gravity that they pull nearby galaxies toward them, messing up the way those galaxies move. This makes it harder for scientists to measure the universe's true speed of expansion. They can't tell if a galaxy is moving because of the universe growing or just because it's being pulled by something huge nearby. And finally, there's gravitational lensing. Light in space travels constantly, but it doesn't always follow a straight line. If the space gets distorted, like by gravity, then the light traveling through the space will get bent and distorted too. Gravitational lensing is when light from faraway galaxies gets bent because it passes by something supermassive, like Quipu here. That huge gravity pulls on the light, like how a heavy ball can bend a sheet. And since light delivers information to us, literally makes us see what things look like, This bending distorts how we see galaxies. The images of galaxies end up looking stretched, brighter, or we can even find an entire galaxy in the wrong place. It's like looking at our universe through a warped magnifying glass. If we're not careful, we could misread those distortions and get the wrong idea about what our world looks like. Luckily, we didn't just drop these mysterious superstructures out of nowhere. Astronomers suspected that something like that should be out there. They just didn't know for sure. Our best model for the universe is called Lambda CDM. It says, universe started with the Big Bang, is still expanding, and is mostly made of mysterious stuff, dark energy, and cold dark matter, the CDM part. We can't see or touch these things, but we know they exist, because if they didn't, our universe would literally break apart. This model matches what we do see, like galaxies forming, how stars move, and the overall shape of the universe. So even if some puzzle pieces by themselves are still a mystery, they match the actual picture. And this model actually predicted things like Kipu. When scientists ran simulations using that model, they saw similar structures forming, giant cosmic webs of galaxies tied together by gravity. Kipu matched those predictions in real life. This also means that Lambda CDM is matching real life once again, thank heavens. No huge surprises here. But now that we actually found it, it's the largest known structure in the observable universe. There was another giant before Kipu, the Sloan Great Wall. That one was discovered in 2003 and was believed to be one of the largest structures ever found. And it's still an absolute monster. The Sloan Great Wall stretches over 1 billion light-years across. It's called a wall, but it's not like a wall you'd find on Earth. It's also a vast cosmic web, made up of thousands of galaxies and gas connected by dark matter. What makes both Kipu and the Sloan Great Wall so surprising is that they literally seem too big to exist. According to the Lambda CDM model, structures that huge shouldn't be common, especially at the time they formed. How did these giants form so fast in a universe that's supposed to be growing, expanding, and smoothing over time? And if we keep finding more of them, that would be completely insane. It could mean there's something deeper going on in the way our world is built. It's all part of our crazy Copernican journey, a long series of discoveries where we just keep getting humbled by the universe. Every time we find something like this, we realize even more how we're not the center of everything. First, we learned the Earth wasn't the center of the solar system. Then we found that the solar system is just one speck in a galaxy. Now, even galaxy superclusters, which we believe to be the biggest, are being dwarfed by structures like Kipu and the Sloan Great Wall. But also, these structures won't last forever. Kipu is temporary. Over billions of years, gravity will tear it apart, breaking it into smaller pieces. Some parts will collapse into tighter clusters, others will drift apart. Right now, though, it's one of the most important structures in the known universe. It shapes how galaxies form. It bends light, making it super important for us to decipher. It literally messes with our understanding of the cosmos.
Spotted. It seems like two giant stars were caught in the middle of a romantic kiss. This sounds a little bit like paparazzi fodder at first, but we're actually talking about a cosmic twist an international team of astronomers has discovered. So, the life cycle of a solo star is relatively simple. They're born in vast, gassy areas of space, burn through their fuel, and at some moment, they explode as supernovae. But when stars are born relatively close to each other, their gravitational pull can cause them some troubles and captivate them into what seems like an eternal dance. In some moments, they come so close to each other that they're practically touching. These stars may spend billions of years circling each other, but their kiss lasts for a few million years only, which is just a blink of an eye in cosmic terms. The lead author of this study was on a mission to find these binary stars caught in such a cosmic kiss. He focused his search on the Tarantula Nebula, a beautiful star-forming region located in the Large Magellanic Cloud, which is 160,000 light-years away from our home planet. And there it was, the shiny double star system that stood out from the rest. The two stars found there were pretty big and nearly the same size. Together, they make a mass of about 57 times larger than that of our Sun. Before this, we discovered only 3 other binary systems with a large mass. And since these two stars were so close to each other, they created an intense gravitational pull. This made them orbit each other at a staggering rate of once a day, with their centers a mere 7.4 miles apart. With the stars being so close, they formed a bridge where their fuel could mingle, allowing for around 30% of their total volume to be shared between the two. Temperatures of this system were crazy too. At first, it seems the internal mixing of their energy might make these stars live longer, as it allows for more fuel to be burned and for longer periods of time. But this is just a temporary benefit. There are 2 most likely scenarios for the star's ultimate fate. They could merge to form one giant star, which would eventually explode into a supernova. Or they could each explode separately and live out their remaining years as black holes orbiting each other. If they merge, this process would probably take around 600,000 years, while if they become binary black holes, they could continue burning for another 3 million years. But both scenarios would ultimately lead to their destruction. Unless the stars could end up as 2 separate black holes drifting away from each other through the vastness of space, there's a possibility for that to happen too. There's something spectacular stargazers across the globe could see recently. Jupiter and Venus, the 2 brightest planets in the sky, ended up so close it appeared like they were about to collide, or as if they were kissing too. At least that's what it looked like from here on Earth. In real terms, they're still 400 million miles away from each other. Here's another interesting thing astronomers like to talk about: G-objects. Those are celestial objects that look like clouds of dust and gas, but behave like stars. At the center of our galaxy, there's a supermassive black hole. It's 4 million times the mass of our Sun, and recently, scientists found out there are 2 mysterious G-objects that hang out pretty close to that black hole, so-called G1 and G2. And the most probable theory is that G2 are 2 stars that were orbiting the black hole in tandem and merged into an extremely large star cloaked in unusually thick gas and dust. During G2's closest approach to the black hole, it showed a strange signature. It was elongated, and much of its gas was torn apart. As it got closer to the black hole, it lost its outer shell, and now it's getting more compact again. The thing that has everyone excited about the G-objects is the material that gets pulled off of them by tidal forces as they sweep by the central black hole. This material must inevitably fall into the black hole, and the result is an impressive fireworks show. This happens because the material eaten by the black hole will heat up and emit radiation before it disappears across the event horizon. An event horizon is that scary boundary around a black hole from which nothing can escape. Now, it seems scientists have discovered 4 more G-objects, and they're all located within 0.13 light-years of this black hole. And it could be that all of the 6 objects used to be binary stars that got together and merged because of the powerful gravity of this giant black hole. Usually, it takes over 1 million years to finish the merging process between 2 stars. We definitely want more G-objects because it's one of the rare opportunities for us to study how things behave near a supermassive black hole without being swallowed. Yet. Have you heard of variable stars? Look up at the sky. We often think of the stars as unchanging, eternal lights. Yes, some stars might appear constant, but others change in brightness over time, which is why we call them variable stars. Some of them dim and brighten again over days, months, or even years. We can't see it with the naked eye. We're talking about changes astronomers can only notice using equipment and over longer periods. And how about vampire stars? Imagine two stars, a red giant and a white dwarf, in a binary system, swirling around each other like cosmic ballet dancers. The red giant, which used to be a vibrant and fiery star, now has aged and grown tired. Its outer layers of hydrogen, which were once held tightly by its gravity, have now weakened, making it vulnerable to the smaller, denser white dwarf. The white dwarf, known as the vampire star, thirsts for the hydrogen fuel that its larger sibling holds, and it sees a great chance there. As they spin together, the vampire star uses its powerful gravitational force to steal the hydrogen from the red giant's outer layers. The vampire star glows with a blue hue, looking full of energy and more youthful and vibrant than its aged dancing partner. Not only vampire stars, the horror continues with zombie stars too. Sometimes when the red giant explodes, it doesn't completely break up into smaller pieces. Instead, a white dwarf remnant is left behind. It's basically a zombie star that was gone at the moment, but has risen back to life. But this isn't your average zombie, hungry for brains. No, this star hungers for the very substance that its vampire sibling had been taking from it all along, hydrogen. And if the zombie star is close enough to its victim, it will start sucking material back in to start its core again. It will become a hydrogen explosive, ready to go boom in a spectacular show of cosmic revenge. It's a fascinating phenomenon. We usually won't even manage to detect it, because these explosions are much fainter than the usual supernovas. But when it does happen, the resulting blast is truly epic. And it destroys both the vampire star and its zombie sibling. It seems vampires and zombies may not be a work of fiction after all. Not only are we made of stardust, but we're also more similar to stars than we thought too. For example, stars also like to hang out with their close group of friends. Most stars prefer to travel through the universe in clusters. It's a group of stars that end up bound together by gravitational force. The stars in the cluster are mostly made of the same age and type, hobbies and interests. I guess even they have better social lives than I do.
Now, it's been a long time since there was a supernova in the Milky Way, over 400 years to be precise. So hey, we're long overdue. So here are the most likely stars to go boom, if they haven't already. At the top of the list must be the Southern Hemisphere star Eta Carinae. Greek letters before the name of the constellation indicate the rank of the star's brightness in that constellation. Sir Edmund Halley, in 1677, recorded Eta Carinae as the seventh brightest star in the constellation Carina, Eta being the seventh letter in the Greek alphabet. It might not have looked very bright to Sir Edmund and his contemporaries in the 17th century, but modern studies of Eta Carinae estimate it's 5 million times more luminous than our Sun. Luminous is a technical word astronomers use. It doesn't just mean brightness. Luminosity refers to the total energy released at all frequencies. Eta Carinae releases 5 million times more energy than the Sun. Truly one of the whoppers of the Milky Way, Eta Carinae is 100 times more massive and 240 times larger than our yellow-white dwarf sun, Sol. Obviously, since it appears dim, Eta Carinae is pretty far away, about 7,500 light-years away. Yet even at this distance, if this star goes hypernova, it can still impact Earth's ozone layer, disrupt satellite communications, and harm astronauts. 159 years after Halley's observation, Eta Carinae experienced a nova-like explosion. It increased from a relatively dim star to become the second brightest star visible from Earth, but only for a period of 27 years. From 1836 until 1863, Eta Carinae was the second brightest visible star after Sirius, the dog star, and Sirius is only about 8 light-years away. Since 1863, aside from a couple of flare-ups, Eta Carinae has dimmed back down to its original brightness at magnitude 4.5. Now, astronomers owe us a small apology, which we don't expect to get anytime soon, for star magnitude nomenclature. The brighter a star is, or planet, or moon, the lower its magnitude. Thus, stars brighter than first magnitude are either zero magnitude or negative magnitude. The full moon, for example, is magnitude negative 13. A magnitude positive 4.5 star, like Eta Carinae, is quite dim as seen from Earth, but it's clearly visible in a night sky without light pollution or clouds if you live anywhere south of the latitude of Cairo, Egypt. 30 degrees north latitude is the farthest north you can see this star. Now, listen up. Eta Carinae is currently up to something. It's been brightening again and is now brighter than at any time since 1864. It's a complex situation. Eta Carinae is really two stars, Eta Carinae A and Eta Carinae, what's your guess? Oh, B. There's a third star nearby that's also interacting with the double star's dynamics. Now, without looking, I'm guessing it's named Eta Carinae C. Good guess. Blown out into two incredibly massive globes of gas that are expanding at 20 million miles per hour, Eta Carinae is, without a doubt, one of the strangest-looking stars you'll ever see. Remember, it's located at a great distance of 7,500 light-years away from us. And if anything had happened to Eta Carinae in the last 7,500 years, like going hypernova, we wouldn't be able to see it, because none of Eta Carinae's electromagnetic radiation would have gotten here yet. Astronomers are keeping a close watch on Eta Carinae because it can go hypernova at any time. Or maybe it already did 5,000 years ago, in which case we'd only have to wait another 2,500 years to see it. Yeah, like I'll put it in my planner. Now, from a list of over 30 likely candidate stars that might go supernova, Rho Cassiopeiae is many astronomers' choice. Another Greek letter, Rho, is the 17th letter in the Greek alphabet. It means that Rho Cassiopeiae is the star with the 17th brightest apparent magnitude in the constellation Cassiopeia. Yet Rho Cass, a nickname, is only one of 7 known yellow hypergiant stars in the Milky Way. It's another whopper. To be seen at magnitude 4.5 from a distance of about 10,000 light-years away, Rho Cass must be a very large star, a hypergiant. Placed where the Sun is, Rho Cass would encompass the orbit of Mars. But it's still yellow. It's not a red giant star. Red indicates a cooler surface temperature. Rho Cass, as huge as it is still as hot on its surface as our Sun, or even a little hotter. That can only mean two things. Deep inside its core, Rho Cass is fusing atoms much heavier than hydrogen or helium. Plus, Rho Cass is producing much more energy than a red giant star. In the year 2000, Rho Cass erupted massively. It brightened by 2 orders of magnitude as it ejected 10,000 times the mass of Earth into space at 4 times the speed of sound. Astronomers detected the signature of titanium oxide in this eruption. This means that Rho Cass is much closer to going supernova, or in this particular case, hypernova, than astronomers used to assume. Iron is just a few steps above titanium in the periodic table, and when iron forms, fusion stops and a star collapses. Rho Cass is really close, or more correctly, was really close, because the eruption we saw in the year 2000 really happened 10,000 years before. Many astronomers think Rho Cass has already gone hypernova, formed a black hole, and doesn't even exist anymore. Meanwhile, Betelgeuse caught everyone's attention not so long ago. The star, not the movie. It dimmed dramatically, appearing only 37% as bright as it usually is. Is it getting ready to go supernova? Betelgeuse is by far the brightest star in the whole sky, in infrared light. This is an important fact because it relates to Betelgeuse's status as a supernova candidate, as we shall soon see. Betelgeuse is also named Alpha Orionis, another Greek letter designation. So we should conclude that Betelgeuse is the brightest star in Orion, right? Wrong. It's the second brightest star in its constellation. Rigel, or Beta Orionis, is the brightest one in that region. Yeah, figure that one out. It may be because Betelgeuse is classified as a semi-regular variable star, which sounds kind of redundant to me. Its approximately 400-day cycle of pulsation changes its brightness by about 1 full magnitude, going from much brighter than a first magnitude star to closer to a second magnitude star. But never was Betelgeuse observed to dim so rapidly or so drastically as it did recently. So what's going on with it? Well, from late 2019 to mid-2020, Betelgeuse went through a period of substantial dimming during a mass ejection event. The world astronomy community jumped on the situation, and in the course of their investigations, they came up with some surprising new factual data on Betelgeuse. First, Betelgeuse is not as far away as we once thought. The new, more accurate distance for Betelgeuse is 548 light-years. That's 25% closer than previously measured. The second new fact, Betelgeuse's diameter has been reduced by the same percentage. The star is now known to be 25% smaller than previously believed. The cause of Betelgeuse's dramatic dimming was also determined. The giant star ejected a cloud of gas that contained magnesium. The cloud blocked a large portion of the light coming from Betelgeuse and made it appear visually much dimmer than it really was. Magnesium is not halfway to iron on the periodic table, which means Betelgeuse is not as far along on the path to a supernova as was suspected previously. When iron starts forming in the star, it means that this star is close to shutting down its fusion reactions. The next step is implosion. We aren't quite there yet with Betelgeuse. This star emits most of its energy as infrared light, and it also indicates that its core is most probably still burning helium, and not something that would greatly increase the amount of heat, like carbon for instance. Betelgeuse will still go supernova, but not for another 100,000 years. So you can cross it off your supernova list for the time being. And as for how to correctly pronounce Betelgeuse, you can say it any way you like. There are as many different pronunciations out there as there are people who think they know how to pronounce it correctly. Now, supernova 1987A caught astronomers off guard when it lit up the Large Magellanic Cloud 100,000 plus light-years away from the Milky Way. That's when attention was turned to a similar star much closer to Earth, Rigel, in the constellation of Orion. Could Rigel surprise us and suddenly go supernova? There's something called the supernova problem that you should, probably know about because it may relate to Rigel going supernova or not. It seems that stars over 17 solar masses don't always go supernova. Recently, a red giant star simply vanished. Once again, it didn't go supernova, it disappeared. This had often been happening in computer simulations of supernovae, and now it finally occurred in real life. Rigel's mass is 21 solar masses. In other words, it's 21 times more massive than our Sun. So, will Rigel go supernova or simply vanish into a black hole that it'll create in its core? Astronomers and physicists continue their work of learning more about the dynamics of massive stars, scouring the sky for the next supernova in the Milky Way. Meanwhile, we can rest confident that we on Earth are in no danger from the harmful effects of nearby supernova explosions. We live in a nice, quiet, peaceful, stellar neighborhood, except for those Martians next door.
When you look at the night sky, it seems like there's not much happening up there, and that the stars always twinkle at the same spot. For thousands of years, researchers followed the idea that the lights in the sky were unchanging. Sailors guided their ships using fixed stellar patterns. There are also the exact outlines of constellations we observe today, and astronomers identified them a long time ago. It seems impossible that one day we wake up and simply can't see some stars anymore. Or does it? A team of researchers at Vanishing and Appearing Sources During a Century of Observations, or VASCO, studied the sky to check how things with the stars are going. The astronomers got the data from Gaia, the European Space Agency, and compared the information from 70 years ago to that from today to see how the sky has changed. To test it right, they had to use both modern and old telescopes. And something really interesting happened up there. Over 700 stars from the old maps were missing. If one star disappears, multiple theories could work. But it's harder when hundreds of them vanished at the same time. Could it be that the data was wrong, or these stars were too faint to detect? Nope, they quickly eliminated this option because these stars had clearly been part of their earlier observations. So, the first thing that comes to mind when talking about how stars disappear is that they reached the point where they ended their lives. You can have the most massive stars of all, And we're talking about those that are way heavier than our sun. And they go through sudden changes as they get to the end, which we also call a supernova. It's a powerful explosion that later shines for many, many months. And it's still visible even across hundreds of millions of light years. But that's the point. You see the traces, unlike here. Could this be a failed supernova? That means maybe one of them collapsed but turned into a black hole and consumed the remains from the inside out without causing a powerful explosion. But no one's been mentioning any signs of a black hole being active anywhere near those stars. And what if the stars had become less visible because of dust or gas around them? This is something that can easily happen, as interstellar dust and gas do block our view of objects that are far away. But there were no traces of unusually high concentrations of dust or gas. Nothing destroyed them either. Researchers would have seen traces if something like that had happened. Plus, these missing stars were not all in the same area, which means there probably wasn't just one fatal thing that made them all disappear. Also, the stars were not at the same stage of their life, so it's not an option they were all accidentally close to their end. They weren't particularly old or young, and they were on different levels in size and brightness. At some moments, it even seemed these stars haven't vanished because of some natural events. Maybe it was something related to other civilizations that might be somewhere out there in space. Maybe that's one of the ways to look for them. We could stumble upon some secret civilizations from other planets if we carefully observed the behaviors of stars, especially those we can't explain. No one knows what exactly happened with the missing stars, and unfortunately, right now, all we have are these theories. But you have to admit, they're cool though. Maybe it's just some kind of optical afterglow caused by gamma-ray bursts, or maybe even fast radio bursts. Fast radio bursts are powerful pulses of radio waves. They can release more energy in a couple of thousandths of a second than our giant sun does in almost 100 years. We don't really understand how these energy eruptions work yet, so we don't know what they can do. But still, hundreds of stars at approximately the same time. There are between 100 to 400 billion stars in our galaxy, so we'll probably see some of them disappear too. Hopefully, we'll understand better why such things can happen. Of course, scientists are not sure about this number because we can't see all of the Milky Way stars from our home planet. Some are too faint, some are too far, or even hidden by dust or gas. But they assume these numbers based on the size, shape, and likely mass of the Milky Way. And out of billions of stars, there are a little over 9,000 of them we can see with the naked eye. If you want to see more, you need a good telescope that will reveal those fainter ones your eyes are unable to discern. Many of the stars we see in the night sky are probably not alive anymore. Stars are giant balls of gas that produce light and heat through nuclear fusion in their cores. However, stars also have a limited lifespan, and eventually they run out of fuel and stop shining. When a star passes, it can either become a white dwarf, neutron star, or black hole, depending on its size. Scientists have discovered that some of the stars we see in the night sky are too old to still be shining. This means that they may have faded, but we are still seeing their light because it takes so long to reach us. Actually, we may be looking at the past when we look up at the stars. Check out all of the stars you can see with your bare eyes. They lie within about 4,000 light years of us. That means what we're seeing are stars that appeared 4,000 years ago. Most of the stars we know of exist within galaxies, which are massive collections of stars, gas, and dust held together by gravity. Still, there are large areas of empty space between galaxies too. And the question is, could they have any stars? It seems that these areas of space are not completely empty. There is still some gas and dust, as well as dark matter, which is a type of matter that we cannot see but we know exists because of its gravitational effects on other objects. Scientists have even discovered a few isolated stars in these areas of space. These stars didn't form there. They ended up there by accident, which means they have probably been ejected from their galaxies by gravitational forces or collisions with other objects. And there could be more of these stars than we realize, but they are simply too dim to be seen from Earth. Stars don't actually twinkle. It's more that we just see it like that from the Earth. It seems like they twinkle because of the turbulent atmosphere of our planet. The light from a star must pass through many layers of the atmosphere. Not every layer is equally dense, so this causes the light to slightly deflect and change in color and intensity. There's one star named Sirius that sometimes twinkles, sparkles, and flashes so much that some people even tend to report it as something extraterrestrial. This is because Sirius is very bright and is often low on the horizon, which means it experiences more of these special effects of the Earth's atmosphere. When in space, astronomers and astronauts who observe stars from there don't see them twinkling. Hey, want to hear something cool? Me, you, your friends, the rest of humanity, we're all made of stardust. The elements that make up human bodies and all life on Earth were formed inside stars. The building blocks of life, such as carbon, nitrogen, and oxygen, were created inside stars and were eventually released into space when the stars were gone. These elements then became part of new stars, planets, and eventually, life on Earth. The iron in our blood was created in the cores of supernovas, which are massive explosions that occur when stars fade. Some say that even the calcium in our teeth and bones is likely to come from exploding stars. The oxygen in our lungs was created in the cores of massive stars before being released into space through supernovas. More than 1 million Earths can fit in our sun. New research shows that between 20% to 35% of suns eat their own planets, and a quarter of planetary systems orbiting stars like the sun had a chaotic past. The very thing that gives life can also take it away. All the planets in our solar system revolve around the sun, and they all do it in a somewhat consistent way. It's most likely that they stayed that way ever since they first came into the picture, but not all of them. This chaotic existence means that a solar system had a lot of planets in the litter until the host sun decided to melt them away. Our solar system is panned out perfectly so that no planet's gravity interferes with each other. The gravitational force on Jupiter is a lot tougher than Earth's, which means that if Earth gets close to Jupiter, we'd be another moon for Jupiter. The planet is so big that if Earth were the size of a grape, Jupiter would be the size of a basketball compared to it. Even with the best technology in the world, it's difficult to tell if stars do, in fact, eat their planets. The best way to study this is to observe binary systems. That's just a sciencey way of saying a system with two stars orbiting each other. Usually, the two stars were formed around the same time from the same gases and the same conditions. It means they should contain the same elements, more or less. When you open your eyes in the morning, the sunlight that's been traveling for millions of miles greets you. The closer we get to it, the hotter it is. But the rays traveling from the sun also contain certain chemicals that make it unique. The chemicals that are associated with the sun are light materials like oxygen, carbon, hydrogen, and helium. You can find some other stuff in it too, but these are the main ones. By studying these elements, you can learn the history of a solar system with enough detail to determine if it was chaotic or smooth. Scientists studied 107 binary systems composed of suns like ours by analyzing the light. Since each system contains two suns, they compared and contrasted them to see the differences. They observed the stars with a thin outer layer, having different elements than their companion. All suns contain light elements, but there are some that have rocky elements, like iron, silicon, and titanium near the sun. These elements are associated with rough terrains that you'd find on the surface, but they're out there floating in the middle of space. The thinnest outer layer is especially rich in iron compared to the other layers. Many stars are twins at birth. Even most of the Milky Way stars have a buddy in a binary system. It means our sun is pretty unique for not having a partner. But there are some theories out there that suggest that the sun may have lost its twin in the past. It's around 184 light-years away and is called HD 186302. This might be our lucky star. A stellar nursery is where thousands of stars are born. They're made up of gas and dust that gradually collapse under their own weight. Our sun may have started in such a way 4.6 billion years ago. And when they're mature enough, they go out into the open, usually with their travel buddy. Actually, scientists claim that up to 85% of all stars could be in binary pairs or have more buddies, but over 50% are dual pairs. The only problem is that we can't really see it, since it strayed from its original orbit an eternity ago. But traces of it can be found in the Oort cloud. That's the vast cluster of space consisting of comets, space rocks, and ice in the outer edges of our sun's reach. They float around quite a lot, since they're far off the sun's gravity and can easily be knocked out of their orbit into open space. Flying through such a space is no different than flying through any random void of space. The reason why some of these light elements in space contain rock elements you'd find on the surface of a planet is because the sun knocked them off their orbit and devoured them as they got closer. It also happens when a star becomes too big in its place and starts eating everything around it. According to scientists, if a star eats a planet, it can make it go chaotic and spin so quickly that it eventually rips apart. But don't worry, there's a very low chance of the sun devouring the planet in the near future. Stars are formed when a huge cloud of hydrogen and helium grows until it collapses under its own weight. The pressure increases and reaches extreme heat levels we can't even measure. Eventually, the hydrogen atoms lose their electrons, causing the hydrogen to fuse together and release energy, countering the gravity collapsing. But when the gravitational force overpowers the hydrogen fusion, the star begins to expand and becomes a red giant. And then, after around 1 billion years, the hydrogen in the outer core will go away, leaving plenty of helium hanging around, which will fuse with the rest of the elements around. And once all the helium disappears, gravity will shrink the red giant into a white dwarf. And when it's completely gone, the remains of the star release tons of gas and dust into space. Scientists claim that our sun has between 7 to 8 billion years left before it reaches that stage. But even if that becomes a reality, it wouldn't happen overnight. Something like this takes millions of years to take place. But what if the sun decided to devour us overnight as we speak? The planet would start feeling hot in seconds. Every slight degree change can lead to some catastrophic events. Ice caps can melt in a matter of seconds and flood the coastal lands. Even little islands in remote areas of the world will be submerged. And as it gets hotter, every snow-capped area will melt instantly and turn into desert-like climates. Some places will burn, and your everyday objects will melt on the spot. The Earth's interior will also get hotter, allowing volcanic eruptions to happen across the world. Antarctica will melt from the heat, as well as the volcanoes erupting inside. And just in a matter of minutes, the whole planet will turn into fire and ash before it explodes into tiny bits floating in space, reaching areas we've never even heard of. But no worries, something like this won't really happen. In case the sun knocks us off our rotation, the results would be different. It'll also get hot because the magnetic field around us protects us from the sun's radiation. And once we get knocked out of place, the magnetic field gets tarnished, and the extreme heat from the sun will boil us. The gravitational force will be unstable, so the physics of our everyday life will be chaotic. We'll have to wait 5 billion years from now when the sun turns into a red giant. It'll grow in size, eventually eating up Mercury and Venus. Chances are, Earth will also be on the menu. If Earth were to move only 900,000 miles closer to the sun, then it would be uninhabitable. It may seem like a lot, but it's only 4 times the distance between the Moon and Earth. Detecting the chemical composition of the sun rays in solar systems that are further away could help scientists find other Earth-like planets. Since the atmosphere around these planet-eating stars changes the chemical composition, we can detect which solar systems out there have had a calm past. The main thing we have to observe is if the planets have a healthy orbit cycle. With nothing else getting in the way, we can assume that the planet could follow the same steps as Earth did for humans to be here. But this process will take ages, since there are millions of nearby stars similar to our Sun. The odds of finding a planet similar to ours are near impossible at this rate. But if so, then there might be life on those planets. There will be no way of knowing if it's intelligent life, but they might have had the same evolutionary fate as us. Hop on board! Hurry, we don't have much time. We're on a cosmic journey to find the biggest star in the universe. The first star we pass is our own Sun. By far, not the biggest one out there, but it's still massive. You could fit 1 million Earths inside it. That means, if you think of the Sun like a basketball, Earth would be half the size of a pencil eraser. If we put all the planets on one side of a scale and the Sun on the other, the planets wouldn't stand a chance. The Sun makes up 99.9% of all the mass in the entire solar system. Mass is basically how much stuff or matter something is made from, and it's what you can thank for stars shining. You see, the more matter in a star, the thicker and hotter its core becomes. This starts a chain of chemical reactions. Hydrogen atoms get smashed into each other to form helium, releasing an incredible amount of energy. That's the star's light and heat. So, bigger stars also equal brighter ones. But with all those reactions going on, this shortens a star's lifespan. When it starts to run out of fuel, the star will enter the giant phase. It'll expand and turn red. Which brings us back to the task at hand. The biggest star we'll find is likely to be on the edge of its life. Switching on our hyper light engines, we soon arrive at the Lumen 16 system. Here, we'll find one of the smallest stars out there, a brown dwarf. Small here means about the size of Jupiter, but they're small for stars. Brown dwarfs are also called failed stars because they don't have enough mass for those chemical reactions. That means they're not as bright, but they're super dense. All the matter in them is packed together so tightly, they weigh 80 times more than Jupiter, even being the same size. And if you think that's something, just look at a white dwarf, even more tightly packed. This one here is Sirius B. It's also about the size of Jupiter, but it'd weigh as much as the Sun. It emits a dim white light. Once it runs out of gas, it'll turn red and cool down. Now let's fly closer to its giant neighbor, Sirius A. You easily see this star from Earth. No telescope needed. Twice heavier and more than 1.5 times wider than our Sun, it's the brightest star in our night sky. Now we fly 550 light-years away from Earth to the constellation Cassiopeia. Almost 100 years ago, a cosmic explosion happened here. It expanded the atmosphere of the star Gamma Cassiopeia, and some gases were thrown into space. After that, it became the brightest star in the constellation. It's 10 times wider than our Sun. On to the famous North Star. Funny enough, different stars have had this title over the years, and more will take it in the future. That's because Earth's pole star changes every 26,000 years. Imagine our planet like a spinning top. The northern pole will shift around in a little circle, pointing at different stars to the true north. The current one is a supergiant 37 times wider and 5 times heavier than our Sun. It's easy to find in the night sky. It's on the very tip of the Little Dipper's handle. Get ready now. We're setting off for the eye of the storm, the center of our Milky Way galaxy. To see the next star, we need to switch to infrared mode. This pistol star is hiding from us in space dust. In just 20 seconds, it emits as much light as our home star does in an entire year. And its size is jaw-dropping. It's 420 times wider than the Sun. But it's still not the most luminous star known to humanity. That would be a blue supergiant in the constellation Triangulum. Meet B416. It's almost 10 million times brighter than the Sun. But the brighter a star, the faster it burns up all its fuel, and the shorter its life. Compared with a red dwarf that barely glows and burns fuel much more slowly, its life will be hundreds of thousands of times shorter. 3,400 light-years from Earth, there's one of the rarest celestial bodies in the universe. It's a yellow hypergiant called Rho Cassiopeia. Among the countless stars in our galaxy, there are only a couple dozen of these. And even though this star is extremely far away from our planet, you can still see it in the sky without needing a telescope. That's because it's 300,000 times brighter than our Sun. It also helps that the thing is 900 times wider than our home star, too. And its color tells us that its fuel reserves will last for a long time. When Rho Cassiopeia starts to turn red and expand, it'll be one of the biggest stars in the entire universe. Now, we move to the constellation Orion. The star is in our sights. Betelgeuse, one of the largest ones visible to the unaided eye. 700 times the size of our Sun. If it took our star's place, its surface would touch the asteroid belt. That's between the orbits of Jupiter and Mars. It would engulf the 4 inner planets, Earth included. But this star has astronomers very excited. They predict Betelgeuse will explode in a fantastic celestial show in the next 10,000 years. It'll be the greatest astronomical event of all time because we'll be able to observe a supernova at a close but safe enough distance. The exploding star will shine as bright as a half moon. It'll be visible in the daytime sky for a year and at night for several more. Now we venture to stars that exceed the Sun's width 1,000 times. Mu Cephei is a hypergiant boasting the title of the reddest known star. Its color tells us that the fuel gauge is getting closer and closer to empty. But it's still so big that it could hold 1 billion suns in it. And because of its mass, this star will eventually become a supernova or even a black hole. Let's take a trip of almost 4,000 light-years from home. Here it is, a red supergiant called VY Canis Majoris. It's one of the biggest and brightest stars of the Milky Way. It could fit 3 billion suns. And even though it's so huge, this thing is surprisingly light, only 17 weights of the Sun. In the context of celestial bodies, you could call this star an inflated balloon. In the next 100,000 years, VY Canis Majoris will explode in a hypernova. Gamma radiation will destroy all life in the local part of the universe. But this star is so far from our solar system that it wouldn't mean any harm to us. If we placed MY Cephei in the center of our solar system, it would bulge all the way out to Saturn's orbit. To remind you just how far away Saturn is, think of it this way. It takes the Sun's light 8 minutes to reach Earth. To get to Saturn, it takes well over an hour. Compared to this massive star, the Sun is just a grain of sand. It's one of the most luminous and reddest stars in our universe. The bigger and redder the star, the closer it is to its end. So, we're not looking at just a titan of the universe, but also one of the oldest celestial bodies out there. The second biggest star in the universe is UY Scuti. It's about 1.5 billion miles wide, 16 times the distance from the Earth to the Sun. This is a pulsating variable star. Its brightness changes about every 2 years. UY Scuti is a record breaker in fuel combustion per year. Scientists expect it to evolve back to hotter temperatures like a yellow giant. Our journey is coming to an end. Before us, we behold Stephenson 218. It takes 20,000 years for light from this star to reach Earth. It's hard not to see this red supergiant on our tiny terrestrial home. It's 2,150 times wider than our Sun. We'd need 10 billion suns to fill its volume. For comparison, the average beach contains only about 5 billion grains of sand. Arcturus, a huge red star. It's just bursting from inside out. The red sea of plasma on its surface rages and pulsates. The star burns anything that comes close to it. And now, plop! Arcturus is gone. But at the same moment, it reappears at the center of our solar system, replacing the Sun. What we see in the sky isn't a small yellow dot anymore, but a giant red ball. It's 25 times wider and 30% heavier than the Sun. Even though Arcturus is a little cooler, it's still a total nightmare for Earth. the distance from our planet to the star is now 25 times less. All the water in the oceans and rivers begins to evaporate. What used to be rainforests are quickly turning into a lifeless desert. But sunsets and sunrises now look amazing. Imagine yourself on the roof of the Empire State Building watching the sunrise. First, you see the light over the horizon. It almost blinds you because Arcturus is 110 times brighter than the sun. Then, the star gradually climbs over the surface. The thick dot on the horizon gets wider and wider. It continues to grow until the red star is everything you can see. Arcturus is now so close that you can even see storms of hot plasma on its surface. There are periodic outbursts and mass ejections. Huge amounts of matter are ejected from the surface of the star at speeds of up to 1,200 miles per second. The matter takes the form of a loop attached to the star at both ends. And you have to wear a super advanced spacesuit to be able to observe such a sunrise. Life on Earth ceased to exist long ago under these conditions, and it's going to get worse over time because every 8 days, Arcturus's brilliance increases, and soon our planet will become more like Venus. It's so close to the sun that the high temperature makes any life there impossible. Okay, let's let our planet cool down a bit and put Proxima Centauri in the center of our solar system. It's not a red giant, but a red dwarf. This star is almost 7 times smaller than the sun and almost 9 times lighter. Now our oceans and rivers are not evaporating, but freezing over. Forests and jungles are covered with snow. In about a week, there won't be a single place on Earth where the temperature is above freezing. Even plants that are used to the cold will cease to exist. They mostly feed on the sun's energy. Now, they begin to starve. But there will still be water deep beneath the ice layer. It'll be heated by the hot core of our planet. Microorganisms will still be able to survive. It's much darker on Earth too. It's like an endless twilight here. Oh, and we can barely see the moon. The thing is, it doesn't produce its own light, but reflects it from the bright sun. With Proxima Centauri instead, the moon will lose its brightness.
Hop on the bright side of life together with our brand new tees, hoodies, and more. Click the link to pick your choice.
But an even bigger problem would be with our orbit. The sun has a certain gravitational force, and it keeps us just in the sweet habitable zone, where we're not too hot and not too cold. Proxima Centauri's gravity is much weaker, and Earth is slowly drifting away from the star. We now run the risk of encountering asteroids flying through space, or even other planets. But the worst-case scenario is if Proxima Centauri simply can't hold our planet, and we fly away into dark space. Then, you can forget about any forms of life here. Now, let's put Sirius at the center of our solar system. It's the brightest star in our night sky. It's only 70% bigger than the sun, but almost twice as hot. So its glow is not only bright, it's sizzling. And its light is not yellow, but somewhere between blue and white. You couldn't go out in the city without sunglasses, or Sirius glasses. Still, you wouldn't want to walk the streets, where the asphalt is boiling anyway. You could literally fry eggs on the curb. Of course, by this time, all life on Earth has long since disappeared. But it's not just because of the temperature. Sirius emits enormous amounts of radiation. Our atmosphere serves as a shield against the sun. But in the case of Sirius, that shield wouldn't be enough. Now, why don't we take a more bizarre approach and make ourselves a double star system? These are 2 stars that revolve around a common center. And there's our Earth, safe and sound. It's all about the size and brightness of the stars. These 2 aren't too big, and they give off as much light as our sun. All that matters to us is that our planet is in the safe zone of the double star system. At sunrise, you first see one star appear from below the horizon, and then, a couple of minutes later, the other. The only problem is that this beauty may soon explode with enormous force. In binary systems, one star is always heavier than its companion. Sooner or later, it starts pulling matter away from the smaller star. Gradually, the bigger star just eats its neighbor. Then the big brother can reach a critical mass and explode. This explosion would be about as strong as a supernova. It would destroy our entire solar system. The light from this explosion would be visible for hundreds of light years away. And after that, there would be a huge nebula in the place of our star system. It's stardust and particles that are left from our world. Going to the realm of the crazy now, a black hole. Yes, there's one at the center of our solar system now. We know black holes are scary, mysterious objects that pull in everything in their path. But even around a black hole, there is a habitable zone. You just have to be far enough away so that it doesn't drag you down into its black abyss. Mercury and Venus would be too close to the black hole, so most likely they'd be torn apart and then head for the event horizon. This is the last stop before hitting the singularity, the heart of the black hole. There are only two problems: light and time. A black hole pulls light in instead of emitting it, so the Earth will quickly become dark and cold. And time goes slower around heavy objects. Near a black hole, 1 second can be equal to weeks or even months away in outer space. We won't feel this difference, but the entire universe around us will develop faster relative to us. Any object can become a black hole if it's compressed to a certain size. For example, the Sun can become one if it's shrunk to a width of 3.7 miles. And even the Earth, if you squeeze it to a width of 0.7 inches, it becomes a black hole. Oh, now there's some little rock lurking in the center of our solar system. It's a neutron star. It's about 18 miles wide. Some meteorites are much bigger than that, but it has a mass comparable to the Sun. So its gravitational force is about the same, and our planet's orbit is intact. But the problem is that neutron stars emit next to no visible light, so it's now permanent night on Earth. Still, it gets very hot here. When a neutron star is born, it can be several times hotter than the Sun at first, but it quickly cools down to the temperature we're used to. So there's a chance that all life on Earth hasn't yet been scorched. Another problem is that these little guys are rapidly spinning and can become pulsars. It's kind of like a powerful spotlight on two sides of a spinning star. Neutron stars also eject radiation at tremendous speeds. These rays will make our planet literally sterile. No life form would be able to exist under these conditions. And now, it's time for the biggest star ever known, Stephenson 218. This red giant is 2,150 times larger than the Sun, and if we place it at the center of our solar system, its edge will lie on Saturn's orbit. So Mercury, Venus, Earth, Mars, and Jupiter are already swallowed by the huge star. Saturn, Uranus, and Neptune are roasting like chestnuts on a fire and will soon evaporate. In fact, this could happen to our Sun as well. The older it gets, the redder and bigger it becomes. It'll eventually run out of its fuel, hydrogen, and the Sun will start to burn heavier elements in its core. This will cause it to expand. Then we'll see more beautiful sunsets and sunrises, but the temperature will become too high. In theory, the Sun will get so big that it'll swallow the Earth, and then it'll explode in a supernova, leaving nothing of our entire solar system behind. Shiny!
On March 24th, European skies were dominated by a glowing, insane blue spiral. The eerie sight kept growing, expanding, almost like the whole Earth was about to get sucked into a vortex. And after a couple of minutes, poof, it suddenly disappeared. Even though it looked like some kind of extraterrestrial tech, there's actually a very human explanation behind it. Photos of this strange swirl started popping up all over Europe, with people sharing them from countries like the United Kingdom, France, Norway, and Germany. But if we really want to figure out what happened, we have to look all the way over to the United States. Turns out, on that same day, SpaceX's Falcon 9 rocket was launched from Florida at around 1:50 in the afternoon local time. So while most people in the US saw clear skies after the launch, it actually caused that strange anomaly in the European skies. And that happened because Falcon 9 is a reusable rocket. So, after launching into space, it releases what is called its payload. And by that, I mean whatever it is carrying, like a satellite. After completing its mission, the rocket itself turns back toward Earth. As it does, it ejects any leftover fuel, which instantly freezes due to the high altitude, forming a spiral pattern because of the rocket's movement. Light then reflects off the frozen fuel, making it visible from Earth. Basically, that's what the blue spiral was, leftover fuel released by the rocket in space. So, should we be worried down here on the ground? I mean, is it dangerous? Well, no. It's not like it was some kind of spacecraft accident. It's just leftovers and light. And this is totally normal for the Falcon 9 rocket. Even though it went viral this time, the same phenomenon was spotted about 4 years ago. Back then, people speculated all kinds of things, like a swirling galaxy moving across the sky, or even an unidentified, unexplained flying object. But nah, it was just one of Elon Musk's space toys. Speaking of which, his space agency is also behind another eerie sighting that's becoming more common. On clear nights, many people have reported seeing a strange string of lights moving quickly in a straight line, almost like a train of stars. Those aren't drones, and they're definitely not perfectly organized shooting stars. These strange lights are actually Starlink satellites from SpaceX. You know, that project that beams high-speed internet from space using thousands of tiny satellites, basically turning the entire planet into a giant Wi-Fi zone. But wait, satellites don't have lights on them. So how is it possible that they look so bright at night? Well, basically, what we're seeing is the sun reflecting off the satellites as they travel through their lowest orbit. And they're only visible if the sky isn't too bright. What's really impressive is that you can see this same event more than once on the same day. That's because Starlink satellites travel at a staggering speed of 300 miles per minute, and they complete one full orbit of Earth every 90 minutes. So, doing the math, that means you could spot those satellites within 2 hours of a previous sighting. Without a doubt, the beginning of the year was busy for skywatchers in the United States. In February, they got to see this stunning, cloudy jellyfish shape taking over the sky. What do you think it is? If you guessed another thing related to SpaceX, you're right. This is another art created by a Falcon 9 rocket. This time, it happened because the rocket was launched during the evening twilight. The light from the setting sun bounces off the rocket's smoke trail, creating this amazing effect. Now, let's move on to Italy, where another creepy event occurred. It was a stormy night, and suddenly, way up in the sky, a giant glowing red ring flashed for just a split second. Nope, it was not an extraterrestrial portal. This is something called an ELV. This happens when a powerful lightning strike sends out an electromagnetic pulse that hits the ionosphere, which is a super high up layer of our atmosphere. When this happens, nitrogen atoms up there get excited and glow red, creating a massive but super quick light show. Another red phenomenon happened in Scandinavia, but instead of a ring, it was more like a streak of light. This is known as a stable auroral red arc, or SAR. Despite the name, it's not an aurora. It's something much rarer. This phenomenon happens when the Earth's magnetic field, which acts like a big protective shield, gets disturbed. This disturbance causes some gas in the atmosphere to get super hot, thanks to a huge electrical current around the planet. What's weird is that only oxygen gets heated up during a SAR, which is why these light shows always glow that same red color. And fun fact, this event is more likely to happen after a big solar storm weakens Earth's magnetic field. It is impressive to see phenomena like this with the naked eye, but the view from outside Earth can be just as stunning. In 2022, an astronaut aboard the International Space Station spotted two bizarre blue blobs of light glimmering in our planet's atmosphere. They happened at the same time, but they weren't related at all. One of them was a massive lightning strike that hit right next to a large circular gap in the clouds. The lightning lit up the surrounding cloud walls, creating a glowing ring around the hole. Another one was caused by the moon. The way the moon was positioned made the sunlight it reflected pass through Earth's atmosphere, creating a bright blue blob with a fuzzy ring around it. And if you're wondering what that weird orange halo is, running parallel to the curvature of the Earth, I've got you. That's the edge of the atmosphere, also known as Earth's limb. And this is what it looks like when viewed from the International Space Station. In Canada, residents of central Alberta were looking up at the sky one night when they suddenly saw something strange. A bunch of vertical beams of light that seemed to be coming from the ground and reaching up into the blackness of space. It sure looked like something out of a science fiction movie, but this is actually just an optical illusion. Yep, it's a visual trick caused by some specific winter conditions. This phenomenon happens when light is refracted by ice crystals. Here's what's going on. When it's freezing outside, tiny ice crystals form in the air. These crystals are super thin and flat, so each one acts like a tiny mirror that reflects light sources positioned below it. Basically, the crystals reflect the light straight up, creating those glowing vertical beams. And it can be caused by any light source, like the sun or the moon. But in most cases, the sources of these light pillars is man-made, like car headlights or streetlights. Even though the phenomenon is completely natural, it rarely happens, and only in very specific situations. First, it has to be freezing cold. On that particular day in central Alberta, for example, the temperature was around minus 30 degrees Fahrenheit. Then, the weather has to be calm, with no wind at all. If a storm breaks out, forget it. You won't be able to see the light pillars. And don't mix them up with auroras, okay? Auroras are mostly seen in high-latitude regions, like around the Arctic and Antarctic. Since they happen way up in the atmosphere, they're visible over large areas. Light pillars, on the other hand, are more localized and concentrated in a much smaller area. But hey, no matter which one you spot, if you're lucky enough to see one of these amazing sights in the sky, you're in for a show you won't forget.
You know, oceans cover around 70% of Earth's surface, and we have only explored 5 to 20% of them. And now, astronomers have found more water, a huge stash floating out there in space by a quasar that's more than 12 billion light-years away. And we aren't talking about just a little puddle. It's a mind-blowing amount of water, about 140 trillion times more than all the water in Earth's oceans combined. It's hanging around a supermassive black hole that's a staggering 20 billion times bigger than our Sun. This black hole is surrounded by a super bright quasar. It gives off as much energy as you get if you gathered 1,000 trillion suns. I can't count that high. Oh, by the way, since light takes time to reach us, we're seeing this quasar as it was when the universe was still very young. Astronomers are sure that the newly discovered water reservoir is the farthest and biggest we have ever found in space. Mark Bradford from NASA's Jet Propulsion Laboratory explains that the environment of this quasar is so unique that it's capable of creating an incredible amount of water. Bradford's team, along with another group of astronomers, has been studying the quasar and the supermassive black hole at its center for quite some time. They've noticed that as the black hole pulls in surrounding matter, it heats up the nearby gas and dust. This process has created a region packed with molecules that have never been observed at such a great distance before. Now, quasars were first spotted around 50 years ago, when telescopes picked up super bright objects way out in space. They're not regular stars. They shine from the centers of distant galaxies and are so powerful they outshine all the stars in their galaxy combined. At the heart of every quasar is a gigantic black hole, which is millions or even billions of times heavier than the Sun. When gas and dust swirl toward the black hole, they heat up and release an insane amount of energy. It makes quasars some of the brightest and most powerful things we've ever seen in space. Looking at quasars is like looking back in time. The light we see from them today has been traveling for billions of years. It gives scientists a peek at what the universe looked like way back in the past. Quasars can help us understand how galaxies formed, how matter spread out, and how the first cosmic structures came together. Some quasars shoot out massive jets of superfast particles. Stretching across space, they can sometimes change entire regions of the universe. But let's get back to that space water, or rather water vapor. When astronomers discovered it, it was floating around the quasar, spread across a huge area hundreds of light years wide. For comparison, just 1 light year is about 6 trillion miles. Even though the gas there is incredibly thin, unlike what we're used to on Earth, it's much warmer and denser than the gas found in most other galaxies, including our own Milky Way. The temperature of this gas is around -63 degrees Fahrenheit, and it's about 300 trillion times less dense than Earth's atmosphere. It does sound extreme, even in space terms, it's unusual. Now, water vapor isn't just another molecule. The very fact that it exists near the quasar hints that the area is regularly blasted with radiation. That's what keeps the gas warmer than usual. To add to the mystery, astronomers also found carbon monoxide and other molecules. In other words, there's plenty of raw material floating around. In the future, this gas could help the supermassive black hole grow even bigger, up to 6 times its current size. But that's just one of many potential scenarios. Some of the gas might get pulled into the black hole, some could form new stars, and some might even get flung out into space. Now, finding water vapor in such a distant quasar means that the basic building blocks of the universe have been around for billions of years. Water is crucial for life as we know it, so its presence so long ago hints that the ingredients for life existed much earlier than we might have thought. But water isn't just important for life. It also plays a key role in how stars and galaxies form. When giant clouds of gas cool down, water helps them collapse, making it easier for new stars to be born. But how did researchers even spot this massive cloud of water? In 2008, Bradford's team started looking for water in space with the help of a special instrument called Z-spec. It was attached to a 33-foot telescope in Hawaii. To double-check their findings, they used another powerful tool, CARMA. That's a group of radio dishes in the mountains of Southern California. At the same time, a different team was searching for water using a telescope in the French Alps. In 2010, the second team found a small hint of water in the distant quasar. It was just one teeny tiny signal. After that, Bradford's group detected more signals. It was all the proof we needed to conclude that an enormous amount of water was actually out there. Now, our floating cloud of water vapor isn't the only place where we've found water beyond Earth. Scientists have recently made a huge discovery. It turns out there are massive reserves of liquid water hidden deep underground on Mars. So, in theory, future astronauts could use this water to support missions or even make Mars a long-term home. But of course, there's a catch. This water isn't sitting in nice, accessible lakes or oceans. It's buried so deep inside Mars that we have no way of reaching it with current technology. Scientists have figured this out by analyzing seismic data from the Mars InSight lander. It picked up some strange seismic activity, and the best way to explain it is by these hidden water reservoirs. Mars still does have some water today, mostly as ice on or just beneath the surface. But that's nothing compared to the massive amounts of water the planet had billions of years ago. The big mystery is, where did all that water go? Scientists think it could have either escaped into space or moved into the planet's interior, where it might now be trapped as liquid reservoirs or ice deposits. The problem? We have no way of measuring how much water Mars lost. So for now, that question remains unanswered. Earth's moon has water too, but not in the way you might think. Instead of lakes or rivers, the moon's water is mostly frozen ice, spread out unevenly across the surface. The cold, shadowed poles are especially full of it, since they never get sunlight. A lot of this ice is also mixed in with lunar soil and buried deep underground, making it super tricky to get to. Then there's Enceladus, one of Saturn's moons. It's tiny, just 314 miles across. It's small enough to fit inside Arizona. I think we should try that. Anyway, when NASA's Cassini space probe arrived at Saturn, scientists expected Enceladus to be a barren, frozen world. But instead, they saw huge plumes of icy particles and water vapor erupting from geysers near the South Pole. That meant there had to be a massive ocean hiding beneath its icy shell, sandwiched between the moon's rocky core and the frozen surface. The fact that this ocean is active and constantly sending material into space makes Enceladus a top candidate for future exploration. We also have Europa, one of Jupiter's moons, and one of the most promising places to search for alien life. Europa has a gigantic saltwater ocean that could be 40 to 100 miles deep. This means it might hold more water than all of Earth's oceans combined. But there's a big obstacle. This ocean is hidden under a thick ice shell, which scientists think is 10 to 20 miles deep. Europa's ocean stays liquid because of tidal forces from Jupiter's gravity. The planet's massive pull stretches and squeezes the moon, creating friction, which heats up the interior, stopping the ocean from freezing solid. And the most exciting part is that scientists think water plumes might be erupting from cracks in Europa's ice, shooting ocean water into space. Now, if that's true, we could potentially sample the ocean without having to drill through miles of ice. But there are still a lot of unknowns. How big are Europa's water reservoirs? How quickly do they refreeze? And how does the intense temperature and pressure affect the ice? Scientists are eager to figure this out because Europa's ocean is one of the best bets we have for finding extraterrestrial microbes somewhere in our solar system.
The moon has always been a source of wonder, myth, and mystery. It lights up our nights, controls the tides, and marks the rhythms of time. But what if the moon isn't what it seems? What if this familiar, glowing orb in the sky is not a natural object at all, but a hollow, perhaps even artificial construct? That's the central idea behind the hollow moon theory. A concept that blends science fiction with ancient lore, and dares to question everything we think we know about Earth's closest celestial neighbor. Let's explore the bizarre clues and strange stories that fuel this unsettling possibility. During the Apollo missions in the late 1960s and early 1970s, NASA astronauts left behind scientific instruments, including seismometers. In 1969, the Apollo 12 crew intentionally crashed a portion of their spacecraft onto the lunar surface. The result shocked mission control. The moon reverberated for over 50 minutes. Scientists said it rang like a bell. This was not a one-time event. Later impacts during Apollo 13 and 14 produced similar results. Long-lasting, deep seismic vibrations that were unlike anything observed on Earth. Some theorists argue that this behavior could be a sign that the moon is hollow or has vast inner cavities. After all, nothing on Earth behaves that way unless it's mostly empty inside. NASA's explanation is more conservative. The moon has a dry, rigid crust with little water content, which allows seismic waves to travel much farther than they would through Earth's moist, fractured interior. Still, the Bell effect remains one of the strangest lunar anomalies on record. In many ancient cultures, there are legends of a time when there was no moon. Aristotle mentioned that the Pelasgians, the ancient people of Arcadia, lived before there was a moon in the heavens. The Zulu people of Africa tell stories of two brothers, Wawane and Mpanku, who brought the moon to Earth, an artificial object, hollow and controlled, which changed the weather and caused great floods. Ancient Sumerian texts also hint at a celestial object that arrived unexpectedly in the sky. These accounts span multiple continents and civilizations, alluding to a world that once turned without a moon. Are these myths simply poetic metaphors? Or could they be distant memories of real events passed down in the only language available to ancient humans, myth and story? The moon is the fifth largest natural satellite in the solar system, and by far the largest relative to the size of its planet. No other moon comes close in size ratio. This alone makes Earth's moon an outlier, but there's more. The moon is precisely the right distance from Earth, about 384,000 kilometers, to perfectly cover the sun during a total solar eclipse. The sun is 400 times larger than the moon, and also about 400 times farther away. This perfect 400 to 400 ratio creates an extraordinary visual phenomenon that allows scientists to study the sun's corona during eclipses. Coincidence? Maybe. But to some researchers, it feels more like design. And then there's the moon's orbit. It's almost perfectly circular, and it's tidally locked, meaning we always see the same face. We never see the far side of the moon from Earth, unless we send spacecraft around it. Why does this object behave so precisely? Is it a natural product of gravitational forces, or something else? In 1970, Soviet scientists Mikhail Vasin and Alexander Sherbakov published a radical paper titled, "Is the Moon the Creation of Alien Intelligence?" They suggested that the moon may be a colossal, ancient spaceship, an alien construct disguised as a natural satellite. According to their hypothesis, the moon might have a metallic outer shell with an inner structure that once supported machinery, life, or monitoring equipment. They compared it to a planet-sized arc that could travel between star systems. While their paper was largely dismissed in the West, it planted the seed for countless other theories. Could the moon be a derelict alien spacecraft? Long abandoned, perhaps watching us still? More recent fringe thinkers have proposed even stranger ideas. Some argue that the moon might not just be a passive structure, but a kind of anchor for a simulated or controlled reality. In this vision, the moon is not just hollow, but alive with technology, possibly operating as a monitoring station, memory regulator, or even a civilization reset button. Ancient floods, magnetic pole shifts, and unexplained disasters. Some theorists claim these events correlate with specific lunar alignments or cycles. Others go further, suggesting that the moon is part of a larger system designed to keep human consciousness limited, trapped in cycles of forgetting and rediscovery. Is the moon helping to shape our very perception of time, reality, and evolution? It's impossible to prove, and perhaps that's the point. Even beyond the big theories, there are many small puzzles that don't quite fit. For example, when scientists first studied moon rocks, they expected to find thick layers of accumulated dust, possibly several meters deep. Instead, the moon's surface dust was surprisingly shallow. Where did all the debris go? Radio signals sent to the moon sometimes bounce back with strange delays, suggesting interior reflections that aren't typical for solid rock. And then there are the mysterious transient lunar phenomena. Sudden flashes, glows, or color changes on the moon's surface. These have been observed by astronomers for centuries, yet remain unexplained. Mainstream science sees the moon as the product of a massive collision in Earth's early history, a fragment of the young planet that cooled into orbit. But for every answer science provides, there seem to be more questions. Why does this object behave so perfectly? Why do myths around the world speak of its arrival? And why does its presence feel so scripted? Whether you believe in the hollow moon theory or not, one thing is certain: the moon is far more than just a rock in the sky. It is a mirror to our imagination, a beacon to our ancestors, and maybe, just maybe, a puzzle we were never meant to solve. Some of the most terrifying conspiracy theories might actually be true, but which of them? Let's figure out. You might have heard about the conspiracy surrounding Project Sunshine, for example. A few decades ago, The US government started a study to measure the effects of nuclear fallout on the human body. And according to some people, authorities were stealing bodies to do radioactive testing. However eerie it sounds, it's partially the truth, but in reality, parts of dead bodies went missing. And because for the research they needed young tissue, they were looking for recently deceased children, and then took samples without notification or permission from the more than 1,500 grieving families. The next conspiracy claims that, during Prohibition, authorities poisoned alcohol to stop people from drinking. Strangely, the truth is even more somber. Even before Prohibition, industrial alcohol contained toxic chemicals. However, between 1926 and 1933, the government ordered manufacturers to add even more lethal substances to prevent bootleggers from turning it into drinkable alcohol. Have you heard about the idea that President Woodrow Wilson's stroke left him unable to govern, so his wife secretly took over? It's actually true. In 1919, Wilson had a severe stroke, which left him debilitated. The government kept the situation under wraps, and Edith Wilson controlled access to the president and made key decisions on his behalf. Basically, she effectively led the country for over a year. This conspiracy is outright creepy. It claims that the CIA experimented with LSD and other substances on unwitting Americans as part of a secret mind control project. Sadly, this was not just a rumor. MK Ultra was a real CIA program. It started in the 1950s with volunteers, but soon escalated to dosing people without their knowledge. Some even suffered long-term psychological damage. Another outrageous conspiracy. The Dalai Lama worked with the CIA. Are you ready to find out the truth? During the 1960s, the CIA secretly sent financial support to the Tibetan resistance against China. Declassified documents confirm that the Dalai Lama received an annual stipend of $180,000 as part of this initiative. Now, do you believe that the FBI spied on John Lennon? Well, Lennon's outspoken opposition to the Vietnam War and his influence on the counterculture movement made him a target. The Nixon administration viewed him as a political threat, so the FBI indeed closely monitored him. But what about you? Could the government use technology to track you? Unfortunately, in the digital age, privacy concerns are very real. In 2016 alone, US agencies submitted nearly 50,000 data requests to Facebook, 28,000 to Google, and 9,000 to Apple. Mass surveillance is likely growing. Even webcams and smart devices could be used for monitoring. The next conspiracy goes like this. Tobacco companies were hiding the dangers of smoking for decades. Unfortunately, even in the 1950s, studies showed a clear link between smoking and lung cancer. However, tobacco companies worked to suppress this information, funding misleading research and marketing campaigns to downplay the risks. One of the most popular conspiracy theories claims that an extraterrestrial is buried in New Mexico. And guess what? The claim is partly true, but not in the way many think. In 1983, Atari's E.T. the Extraterrestrial video game flopped so badly that the company dumped thousands of unsold cartridges in a landfill in the New Mexico desert. This sparked urban legends about something more mysterious. The truth was only revealed when the site was excavated in 2014. And how about the Illuminati, a secret society controlling the world and having ties to the NSA? While many believe in the existence of a shadowy elite pulling the strings, the only proven connection between the Illuminati and the NSA is a digital coincidence. Typing Illuminati backward, Itanimuli, into a web browser redirects to the NSA's website. Most likely, this is the work of a prankster who purchased the domain. One of the most eerie conspiracies involves the Bohemian Grove, a secluded retreat in California, where influential figures from around the world gather annually. Today, powerful individuals meet there every July for what is officially described as a casual retreat. However, history suggests that significant discussions take place. The early ideas for the Manhattan Project, which led to the development of the American nuclear bomb, were conceived here. Security at Bohemian Grove is strict, and access is invitation only. Very few photographs of the gatherings exist since photography is prohibited. Women are traditionally not allowed to attend. There are reports of unusual ceremonies taking place around a massive owl statue at the site, but the true nature of these rituals remains unknown. Did you know that in 1958, two powerful rivals planned to take the lead in the space race by launching an atomic bomb at our natural satellite? What would have happened if they had gone through with it? Who the hell thinks bombing the moon is a good way to win a popularity contest? On top of that, we're going to find out if anyone ever did bomb outer space and why. Stick around, because what we're about to tell you sounds incredible, but it actually happened, and even Carl Sagan was involved. It's not like there weren't better ways to grab attention, but let's be honest, who wouldn't want to see some space fireworks? That was pretty much the thinking behind the US Air Force's secret project, A119. This top-secret initiative aimed to launch a nuclear bomb at the moon, hoping the explosion, with enough megatons, would be visible from Earth with the naked eye. To understand why such a wild idea could even seem reasonable at the time, we need to look at the context. In the 1950s and 60s, international tensions were sky high. The aftermath of World War II and the rise of two rival superpowers, the United States and the Soviet Union, led to the Cold War and the famous space race. That race brought incredible scientific advancements: artificial satellites, robotic landers on the Moon, Venus, and Mars, the first human orbital flight, and eventually, the first moon landing in human history. But not every project launched during the space race was a win. Some were total failures, or worse, absurd and dangerous ideas that cost governments tons of money just to prove who had the bigger rocket, so to speak. Project A119 also aimed to answer some questions in planetary astronomy and astrobiology. Like what, you might ask? Well, for example, what would happen if a nuclear bomb exploded on the moon? A very original study, you have to give them that. Despite its age, it remains one of the few declassified reports on the topic. And to make this case even more interesting, young Carl Sagan was part of the team. He was responsible for predicting the effects of a nuclear explosion in vacuum and low gravity. This bold idea, to detonate an H-bomb on the moon for everyone on Earth to see, seems to have been sparked by a rumor published in the Pittsburgh Press in 1957. The article claimed the Soviet Union was planning to celebrate the anniversary of the October Revolution with a big bang on the moon. The explosion would take place at the moon's terminator, the boundary between its lit and dark sides. Apparently, Project A119 also considered the terminator as a target. The article also mentioned that if the Soviet missile missed, it would fall back to Earth and disintegrate in orbit. But what it didn't mention were the even bigger consequences if it did hit the lunar surface. But wait, what could possibly go wrong? The moon's super far away, right? Well, a lot could go wrong. It depends on the bomb's yield, of course, but what if a 100 megaton bomb exploded on the moon's surface? That would trigger a series of very unfortunate events. Since the moon has no atmosphere to dampen the blast, there would be no shockwave like on Earth. With nothing to contain or slow it down, the explosion would just keep expanding monstrously. Terrifying, right? But that's not all. The moon would experience a massive quake that could shake the entire body. Though, to be fair, back in 1958, there were no lunar bases to destroy, so that wasn't a big concern yet. The impact would pulverize the lunar surface, launching dust and debris into space in all directions, including Earth's path. Many of these micrometeorites could rain down on our planet, causing damage. While the blast on the moon wouldn't go on forever, it would eventually cool and lose energy. The leftover radioactive material would slowly settle back onto the surface. And without natural processes like Earth's rain or erosion to clean it up, the radiation would stay there for a very long time. So, what eventually happened to the US's Project A119 and the Soviet Union's Project E? Well, what had to happen? Both were scrapped due to the extreme risks and the possible impact on future lunar colonization. Now, a question some of you, especially Star Wars fans, might be wondering is, were there no more plans to blow stuff up in space after that? And the answer is, oh yes, there were. It wasn't exactly a bomb, but in 2009, NASA deliberately set off the equivalent of about 2 tons of TNT with the LCROSS, Lunar Crater Observation and Sensing Satellite. The goal was to see if there was frozen water in the Cabeus crater on the dark side of the moon. They crashed the probe into the moon, and the mission was a total success. Yes, there's water on the moon. Also, during the Cold War in 1962, the US launched Project Starfish, the largest nuclear detonation ever carried out in space. It was a high-altitude test that caused a massive electromagnetic pulse so strong that it messed up the very instruments meant to measure it. It even affected Hawaii, causing about 300 streetlights to go out, triggering burglar alarms and damaging phone lines. Now you know who and why someone wanted to nuke our dear satellite. But as it turns out, we couldn't change the moon's orbit or get a fireworks show that easily. The moon's too massive and the consequences are way too dangerous. But hey, it's all just a cold case now, right? There's no one still trying to prove who's bigger and stronger by nuking stuff. Right. Let us know in the comments if you already knew about this case, and until next time.
Count how many times the word moon is said in this video. Enjoy! There might be moons out there in space. These are moons orbiting other moons. Online, these fascinating hypothetical space objects have already been nicknamed submoons, grand moons, moonitos, moonates, and even moons. They might not exist in our solar system or any other. But some astronomers claim that the concept of a moon bringing up its own baby moon is quite plausible. The thing is, in all planetary systems we know about, natural satellites occur in a strict order. Planets orbit stars, and moons move around planets. But then, why can't submoons orbit moons? Take Earth's natural satellite. It's so massive that some astronomers even want to call it a planet in its own right. Then why shouldn't this planet-sized moon have its own satellite? In a new paper, a couple of researchers looked for a mathematical answer to the puzzle of moons. Using special equations created to show the tidal effects of planets on their moons, the scientists determined that submoons could exist if the host moon was massive enough and the submoon was small enough. Plus, there should be a wide orbital gap between these two moons and the host planet. This way, a 6-mile wide submoon could only survive moving around a 600-mile wide moon on a wide separation orbit. If these parameters are not met, the tidal forces of the host planet would be too powerful and would smash the moon and the moon together. Or these forces would be too weak to keep the submoon, and it would get jettisoned into space. Based on these conditions, there are quite a few natural satellites in our solar system that could hypothetically host baby moons of their own. These could be Saturn's moons Titan and Iapetus, Jupiter's satellite called Callisto, and our moon. Yes, our own moon could have its own tiny satellite. Why doesn't it? The researchers haven't found the answer to this question yet. The existence, or lack thereof, of moons may shed light on satellite formation and evolution in planetary systems. But once we find the answers we're looking for, the next logical question may arise. Can a moon have a moon of its own? If so, what name would be the most suitable for such a space body? A great grand moon? Write your variants in the comments. Besides hypothetical moons, there are loads of other bizarre things in the universe, the existence of which we haven't proven yet. Hypothetical nuclear pasta is one of them. If it does exist, nuclear pasta is the strongest material in the entire universe. It forms from the leftovers of extinguished stars when this substance gets squeezed into spaghetti-like tangles of material. It can theoretically break, but according to estimates, it could only happen if you applied 10 billion times the pressure you'd need to shatter steel. Then, there's dark matter and dark energy. We kinda know these things exist, but no one has seen them yet. Everything on Earth, and everything people can observe in space with the help of telescopes and other instruments is normal matter. It's made up of atoms and molecules and adds up to less than 5% of the universe. Almost 3/4 of the universe is dark energy. Astronomers wouldn't even know the thing existed if several decades ago they hadn't found out that the expansion of the universe wasn't slowing down. Quite the opposite. It was accelerating. It meant there had to be some enigmatic force that counteracted gravity. It was dubbed dark energy. As for about 27% of the remaining universe, it's believed that it's made up of dark matter. If dark energy is a force responsible for the expansion of the universe, dark matter is supposed to explain how objects work together. Potential candidates for dark matter vary from strange particles to super dim objects. But even though astronomers can't grasp what exactly dark matter is, they know for sure what it isn't. It's dark, which means we can rule out visible stars and planets. It also can't be dark clouds of normal matter, otherwise, scientists would be able to detect it. Dark matter is not antimatter. Astronomers don't see unique gamma rays that appear when antimatter comes in contact with matter, and neither is dark matter gigantic, galaxy-sized black holes.
On a cold January night in 1978, two neighboring military installations, Fort Dix Army Base and McGuire Air Force Base in New Jersey, became the stage for events that might have forever altered our understanding of extraterrestrial presence on Earth. Known as the Fort Dix Incident, this case remains one of the most enigmatic and heavily classified stories in military UFO encounters. A quiet night, shattered by the unexplained. Around 3 a.m. on January 18, 1978, Security Patrol Officer Sergeant Jeffrey Morse was conducting a routine perimeter check at McGuire Air Force Base. Everything seemed normal until radio chatter reported unidentified flying objects hovering over nearby Fort Dix, moving in tight formation and emitting an eerie bluish-green glow. Radar operators soon confirmed the anomaly. These objects maneuvered in ways no known aircraft of the time could. They hovered, changed direction abruptly, and vanished from radar screens as if toying with their observers. A close encounter turns violent. By 3:30 a.m., the situation escalated dramatically. A military police officer at Fort Dix, patrolling a remote section of the base, radioed that an oval-shaped object with no visible features had descended over his vehicle. Suddenly, a humanoid figure, about 4 feet tall, with grayish-brown skin, an oversized head, and elongated arms, appeared in front of him. Panicked, the MP drew his sidearm and fired 5 rounds into the being, followed by a 6th shot at the hovering craft. Immediately, the UFO shot upward and vanished, while the wounded creature fled toward the fence, separating the two bases. The cleanup operation. Within minutes, a team of unidentified soldiers in blue berets, with no insignia, arrived, cordoning off the area and pushing back regular personnel, including Morse. Witnesses later described how the team sprayed the body with an unknown substance, covered it with a white sheet, and placed it inside a large metallic container marked with blue symbols. By dawn, the container was loaded onto a C-141 cargo plane bound for Wright-Patterson Air Force Base, a facility long rumored to house classified UFO-related materials. Aftermath: enforced silence. 2 days later, Morse and other witnesses were flown to Wright-Patterson for interrogation. In a stark room facing 3 men, one a silent civilian with a pipe, Morse was forced to sign a lifetime non-disclosure agreement. Soon after, all involved personnel were reassigned to overseas bases, effectively scattering them across the globe. Morse was sent to Okinawa, Japan, where he spent 2 years before finally breaking his silence. Fact or fiction? In 1980, Morse reached out to UFO researcher Leonard Stringfield, sharing his account. His story gained credibility when Major George Fuller, an intelligence officer stationed at McGuire, confirmed unusual activity that night, mentioning that something was found dead on the runway, though details were withheld from him. Skeptics argue the incident could have been a test of a military biodrone or experimental entity, a psychological operation, PSYOP, to study human reactions, an elaborate hoax or misidentification, yet the military's extreme response, immediate witness isolation, rapid evidence removal, and lifetime gag orders suggests something far more extraordinary. Conclusion: a secret still waiting to be uncovered. Over 45 years later, the Fort Dix incident remains buried in secrecy. If Morse's account is true, this could be the first documented case of military personnel killing a potential extraterrestrial being. Until classified documents surface, key questions linger. Was this a genuine extraterrestrial encounter, or an elaborate cover-up for advanced military technology? One thing is certain: that night in 1978 changed the lives of those involved and left behind more questions than answers. What do you think? Could this really have happened? Or is it just another military urban legend?
Imagine simultaneously being born, growing up, and getting old somewhere out there in the universe. Sounds bizarre and unrealistic. And still, according to the block universe model of the world, that's exactly what happens with you, me, and other living beings on our planet. It's as if someone drew pictures about every moment of your life and then just piled them one on top of another, creating a giant block of all things that ever happen at any time and at any place. The future, present, and past exist at the same time and are equally real. The block has 4 dimensions. 3 of them are spatial. It's length, width, and height. There's one more: time. To make it easier, let's picture our world as a cuboid, which is basically a 3-dimensional rectangle. Its height and width represent 2 of the 3 spatial dimensions of the universe. As for the 3rd spatial dimension, we'll replace it with time. At one end of the cuboid, we'll drop the Big Bang. And at the other, there will be the end of the universe. Let it be a big crunch. Our cuboid is filled with every single event that ever happens. Even this moment, when you're watching this video, exists somewhere in the block. Now, we perceive today as the present, yesterday as the past, and tomorrow as the future. From this perspective, it seems that time passes. But in the block universe, time doesn't flow. There's no specific present moment since the notions of the past and future are relative. You see, we are always located wherever we are, which means that everyone remains in the present. But the block universe theory doesn't deny the notions of earlier than and later than. These relations remain no matter what, and regardless of where anyone is located. For example, Molly the mammoth is located earlier than Marcus the tiger.
This relation between Molly and Marcus will remain unchanged regardless of whether you're located later than Marcus or earlier than Molly. This way, in the block universe, now is any time you are located at. Past is any time or events that are earlier than your location, and future is any time or events that are later than your location. It sounds like in the block universe, we could travel in time since it's just another dimension. Well, it could be true, but of course, things just have to be more complicated than that. Traveling in time is way more difficult than traveling in space, but it's not impossible if you travel very, very fast. Traveling at extremely high speeds results in time dilation. We can travel into the future at a reasonable percentage of the speed of light, and to get to the past, we can use wormholes, shortcuts through space-time. But if we can travel in time in the block universe, can we change the past? Not really, because if you do, it'll create a contradiction. Keep in mind that, in this universe, the past is the same as the present or the future. What is past to you is future to someone else. And when traveling to the past, you're going to someone else's future. In the past, you'll act just like you do in the present, but you won't be changing the past. All your actions are already predetermined in the block universe. At the moment of the Big Bang, it's already clear that at one point, you'll travel to the relative past. Just like what you do tomorrow makes tomorrow the way it is and has always been, what you do in the past makes it the way it is and has always been. The events in the block universe do not change. As a time traveler, you don't suddenly appear in the past. It's always been the case that you're located in the past. And nothing a time traveler does can change anything in the block. Instead, whatever you do at any time makes that time the way it is.
Night enveloped the desert above Heracleion. A group of archaeologists moved through the labyrinth of sunken ruins, illuminating their path with powerful flashlights. Suddenly, one of the researchers, Dr. Martin Hale, stopped in front of a temple wall. He carefully brushed away a layer of sand and discovered a strange bas-relief. A woman holding a creature with an unusually elongated head and enormous eyes. "This can't just be a stylized depiction of an infant," whispered his colleague, Alice Carter. "The Paracas skulls in Peru have similar shapes. Could this be evidence of hybrids?" The question remained unanswered, but the mystery of Heracleion continued to intrigue scientists. Theories ranged from ancient cults to contacts with extraterrestrial civilizations. However, biologists established that elongated skulls could be the result of artificial cranial deformation, a practice common in ancient times. No DNA analysis has shown traces of non-human genetics. Meanwhile, in another part of the solar system, the Viking 1 probe transmitted an image to Earth of a rock formation on Mars resembling a human face. The photograph instantly became a sensation, fueling conspiracy theories. "It's just pareidolia," astronomers stated. "The human brain is wired to recognize familiar shapes in random forms." Decades later, when NASA sent more advanced spacecraft, images confirmed that the face on Mars was merely an ordinary hill, with shadows creating the illusion of facial features. However, proponents of the ancient Martian civilization theory insist that the truth is being concealed. No less mysterious are the artifacts of the Maya civilization. Their bas-reliefs depicting beings resembling astronauts, their complex astronomical calculations, and myths of gods descending from the heavens suggest possible contact with extraterrestrials. Some researchers associate Kukulkan, the feathered serpent god, with alien beings. However, historians remind us that such imagery appears in many cultures and may carry purely symbolic meaning. In Scotland, on Arthur's Seat Hill, children stumbled upon 17 miniature wooden coffins with tiny figurines inside. The origin of these remains unresolved. Were they ritual offerings, connected to the murderers Burke and Hare, who sold their victims' bodies for medical research, or simply children's toys mistakenly perceived as something mystical? Some theories suggest they could have been a form of symbolic burial for souls who never received a proper grave. Others believe they were connected to an ancient superstition meant to ward off evil spirits. Another hypothesis suggests they were linked to an old Scottish practice of making talismans for protection against supernatural forces. The Antikythera mechanism found off the coast of Greece is another ancient enigma. This intricate device, over 2,000 years old, turned out to be an astronomical calculator ahead of its time. Studies revealed that the mechanism was used to calculate planetary movements and eclipses, proving the advanced knowledge of ancient Greek science. Many researchers now believe that similar devices might have existed, but no other examples have been discovered. Recent images from the Perseverance rover uncovered mysterious square structures on Mars. Geologists attribute them to natural crystallization and erosion processes, but UFO enthusiasts are convinced they are ruins of ancient constructions. The formations bear a striking resemblance to rectangular patterns seen in some ancient Earth structures, further fueling debates about potential past life on the Red Planet. In Germany, during excavations near Marburg Castle, students discovered a pocket sundial. The miniature device, several centuries old, amazed researchers with its precision and craftsmanship. Who owned it? Was it part of monastic heritage, used for prayers on a strict schedule? Experts believe that such sundials were rare and expensive, likely belonging to high-ranking individuals or scholars deeply engaged in astronomy and mathematics. Yet one of the most intriguing discoveries remains the Sabu disk, a 5,000-year-old artifact from Egypt. Its purpose remains debated. Some believe it was a ritual object, while others think it had a technical function, possibly part of an ancient machine. Some engineers speculate that its shape suggests it could have been part of a primitive flywheel or a component of an unknown mechanism. Certain studies suggest it could have been related to liquid movement or even served as a part of a lost mechanical system. Despite extensive research, its true function remains an enigma, adding to the ongoing fascination with the technological capabilities of early civilizations. The world is full of mysteries. Every solved enigma raises new questions. Were these artifacts merely the result of human ingenuity, or evidence of contact with forces we have yet to understand? As new discoveries emerge, the past continues to challenge our understanding, reminding us that history holds secrets waiting to be uncovered.
It was the year 2015 when U.S. Navy pilots flying training missions off the East Coast saw something truly eerie. They spotted oval-shaped objects moving quickly over the water. They seemed to rotate as they flew. At first, the pilots thought it was just one object, but soon they realized there were many of them, moving in unusual ways. These objects didn't look like normal aircraft. They didn't have visible engines, didn't produce exhaust, and didn't just hover near the sea like helicopters would. Some of them appeared at altitudes of 30,000 feet and were moving faster than the speed of sound. The strangest and scariest thing? The pilots had been observing similar objects almost every day for months. Mind you, those weren't rookie pilots. One of them was an experienced pilot with 10 years in the Navy. He, along with his fellow pilots, knew what typical aircraft looked like and how to stay calm under pressure. It wasn't until 2019 that the public heard about those sightings. That's when the New York Times published an article revealing them. The article included video footage taken by the pilots' plane cameras, which was later confirmed by the US Navy in April 2020. The Navy officially released the videos soon after. In recent years, sightings of UFOs, now called unexplained aerial phenomena, have been reported by other reliable sources as well. The US government has started to take these sightings seriously and has even brought in scientists to quietly investigate what might be behind them. So far, we still don't know exactly what the pilots and others have seen. But this growing scientific interest is pushing us closer to finding out more. While military pilots reporting UFOs might be a recent development, the public has been observing and reporting them for decades. In fact, the UFO craze in the US can be traced back to the summer of 1947. On June 14th of that year, a rancher discovered strange debris on his land near Roswell, New Mexico. At first, he thought it was from a kite. But even after looking through the bits of rubber, tinfoil, paper, and wood, he still couldn't make sense of it. The rancher then told the local sheriff about his find. And since his ranch was close to the Roswell Army airfield, the sheriff reported it to the military. Officers came to check it out, and couldn't identify the wreckage either. The next day, but just a few days later, the Army changed its story, claiming the debris was from a weather balloon. By then, though, the excitement over UFOs had already sparked, and UFO fever spread across the nation. Now, UFOs are real, in the sense that people have indeed seen objects they can't identify in the sky. But when people ask, are UFOs real? They usually mean, are we being visited by aliens? And science doesn't have an answer to that yet. After the Roswell incident, UFO sightings became more frequent. People made wild claims, saying they'd met aliens or even been abducted. These stories were mysterious and captivating. No wonder they gained traction. The government didn't help much since it was keeping its own secrets. Eventually, they admitted to hiding something, but it wasn't little green men from other planets. In 1995, the Air Force released a report explaining that the debris found on Brazel's ranch wasn't from a weather balloon, but from Project Mogul, a secret Cold War program that used balloons to detect missile launches of certain countries. As for the alien bodies people claim to have seen, they were crash test dummies used in experiments with ejection seats. In 2021, the US government released a brief report on UAPs, aka unexplained aerial phenomena, stating that they have found no evidence of aliens. At the same time, they acknowledged that many UAP sightings had been recorded since 2004, and those remained unexplained. According to the report, those sightings did not necessarily point to alien spacecraft. Some could be birds, debris like party balloons, secret military projects, or even new technology from other countries. In May 2022, Congress held a public hearing on UFOs, and high-ranking military officials testified there. They revealed that since 2021, 400 unexplained sightings had been documented, but none suggested extraterrestrial life. At the same time, there's more and more evidence hinting that Earth may not be the only place with life in the universe. Earth itself is 4.5 billion years old, and life emerged here around 3.5 to 4 billion years ago. Life on Earth began fairly quickly, which means that the process of life forming wasn't overly difficult. And if life could begin easily on Earth, it's likely that it could also start on many other planets in the universe. The Milky Way galaxy alone contains 1 trillion planets, and there may be trillions more in the universe. Given these numbers, there is a lot of potential for life elsewhere. However, just because there's a possibility of life elsewhere doesn't necessarily mean that aliens have visited Earth. That's why SETI, Search for Extraterrestrial Intelligence researchers, are focused on detecting signs of life elsewhere in the universe, not on studying UFOs. For a long time, most scientists dismissed the study of UFOs as pseudoscience. That's why many researchers interested in UAPs, unidentified aerial phenomena, stayed silent to avoid being seen as eccentric. But this has started to change. In June 2022, NASA created a team of scientific experts to search for the unknown in air and space. The researchers suggested using NASA's huge amount of space data to assist in the study of UAPs. The team also made it clear that studies of UAPs should focus on evidence and data, not speculation. Instead of simply collecting stories or relying on accidental sightings, the researchers used telescopes to capture footage of the sky. They gather this data and then analyze it with the help of artificial intelligence. They plan to add more observatories, and over 100 scientists are already involved. Astrobiologist Julia DeMarines suggests that some UAP sightings could be caused by unusual weather conditions. For instance, spacecraft launched near sunset can create strange effects. The gases expelled by spacecraft reflect only the light reaching the upper atmosphere at that time. And since the sunlight remains reflective for a long period, such sightings can seem unexplainable. UAPs might also be caused by light reflecting off communication satellites. But could UAPs really be alien spaceships? People often expect first contact with alien life to be dramatic, but the reality might be more subtle. Our first encounter with alien life may actually be discovering their technology. For example, we might find a piece of space debris that didn't originate on Earth, like spotting an empty plastic bag blowing through space. We'd know it didn't come from Earth, but we wouldn't know where it came from. Another possibility is that the aliens we might encounter may no longer exist. In 1961, astronomer Frank Drake developed the Drake equation, which estimates how many alien civilizations might be capable of sending signals. The equation considers factors like the rate at which stars form and the number of planets capable of supporting life in a Goldilocks zone, a habitable zone located at the right distance from a star for water to remain a liquid. However, one key factor in the equation is represented by L, which stands for the length of time technological civilizations produce detectable signs of their existence. Humanity has only been technologically advanced for a little over 100 years, in a universe that is nearly 14 billion years old. It means that the timing for civilizations to overlap might be rare. Many civilizations might have existed before us, and many may come after us, but the chance that we overlap with theirs is slim. Despite this, some scientists believe that it won't be long before we find definitive evidence of alien life.
Did you know that reports of strange object sightings are quite common? The British Ministry of Defense reports at least 100 UAP, unidentified aerial phenomena, sightings every year. That means there have been at least 2,400 reports in that country alone since the year 2000. A UAP is considered to be anything that cannot be immediately explained or identified. Usually, most reports find an explanation, such as atmospheric phenomena or known objects. However, the portion that remains unexplained is undoubtedly the most intriguing. Throughout history, there have been waves of sightings. One of the most well-known occurred in 1947, famously referred to as the flying saucer madness. That summer saw a flood of reports across the United States, with approximately 800 sightings that year alone. On that occasion, a local news story reported by a civilian pilot named Kenneth Arnold claimed to have seen disc-shaped objects traveling at speeds of around 1,200 miles per hour in a line of 9, passing over Mount Rainier. This was the first post-World War II sighting and is considered the report that marks the beginning of the modern UFO era. Returning to this century, there are at least 15 well-known cases. Let's examine some of the most striking examples. Number 1. The first case we'll look at has even sparked NASA's interest. It concerns the unexplained activity in a small town in the United Kingdom called Bonsall. Residents have reported and documented numerous cases of unexplained activity, earning it the nickname UFO hotspot. Reports range from silver shapes to strange lights in the sky. In 2001, Sharon Rowlands accidentally filmed a house-sized disc with colored lights around it. The video caught NASA's attention because it resembled an object spotted during a 1996 space mission. However, the only conclusion NASA reached was that the object was metallic and didn't match any known commercial or military aircraft. Number 2. This case is from 2004 and concerns the Tinley Park lights in Illinois, United States. Residents reported inexplicable lights in the sky, which were also seen in neighboring cities like Chicago. Witnesses claimed to have seen a triangular pattern of red orbs hovering over the town. Other witnesses stated that the lights displayed a range of colors, from amber to greenish yellow. Skeptics who saw the lights firsthand dismissed them as an elaborate prank, but no definitive explanation was found. The lights were seen twice that year and remain a mystery to this day. Number 3. The next case involves some of the most viewed footage of sightings. The unexplained videos from 2004, 2014, and 2015 recorded by pilots of the USS Nimitz and USS Theodore Roosevelt. The fighter jets managed to capture these strange flying objects using their infrared tracking cameras. In 2021, the Pentagon officially confirmed the authenticity of these recordings. Fighter pilot Commander David Fravor of the Nimitz stated that the object had been appearing for 2 weeks when he was called to investigate the case. The object appeared at an altitude of 80,000 feet, descended rapidly to 20,000 feet, and then hovered. Fravor reported seeing an oval-shaped object approximately 10 feet, 3 meters long flying over the ocean. He and other pilots accompanying him stated that they were able to observe the object for about 5 minutes before it disappeared. It was Commander Chad Underwood, in a second wave of investigation and equipped with an infrared camera, who managed to capture the first video, showing the object's erratic movements. Number 4. This case occurred in 2006 and is known as the O'Hare International Airport sighting in Chicago. Around 4:15 p.m., 12 United Airlines employees and several witnesses outside the airport saw an unidentified flying object resembling a flying saucer. The object was hovering over gate C-17. It was also seen by pilots, airline staff, and mechanics. Witnesses described it as completely silent and dark gray in color, adding that it clearly wasn't a cloud. A witness claimed that the object shot upwards at incredible speed, leaving a hole in the clouds that quickly closed. Despite numerous testimonies from people shocked by what they saw with their own eyes, authorities refused to pursue an investigation, as the alleged craft did not appear on any radar. Number 5. This case was cataloged as the 2024 New Jersey drone sightings. Interestingly, the appearances occurred on both the east and west coasts of the United States multiple times. These large, unidentified drones were seen near residential areas, power plants, railways, highways, and critical infrastructure, such as ports, bridges, and police stations. Over 3,000 reports were collected, but investigators couldn't determine an explanation. The Department of Homeland Security stated that the drones were manned aircraft operating lawfully. At the same time, the federal government called for legislation and additional resources to address the drone activity. According to a legislative briefing, the drones were up to 6 feet, 1.8 meters in diameter, operated for 6 or 7 hours, often turned off their lights, acted in a coordinated manner, and evaded detection. They most certainly did not seem to be flown by hobbyists. To this day, the operators or points of origin remain unidentified, but official investigations attributed most of the drone sightings to manned aircraft or misidentifications caused by nighttime illusions. Some even suggested mass hysteria, recalling the notorious 1947 flying saucer madness. Which of these cases sent chills down your spine? Let us know in the comments. And if you're curious about the latest unidentified phenomena, don't miss our video on the FBI's recently published UFO documents. Are we alone in the universe? It's a question we've all asked ourselves, perhaps on a quiet, starry night, while gazing at the constellations and feeling small in the vastness of the cosmos. But what if science could actually answer it? Astrophysicists have been pondering this for decades. Back in the 1960s, a groundbreaking formula was introduced to estimate the chances of intelligent life within our galaxy, the Milky Way. It's called the Drake equation, and it was the first logical attempt to tackle this profound mystery. But here's the exciting part. After decades without a formula surpassing Frank Drake's, scientists at Durham University in England have introduced a brand new model that could help us understand the odds of life existing across multiple universes. Intrigued? Let's dive in. Frank Drake, a radio astronomer and SETI pioneer, introduced his famous equation in 1961. He aimed to estimate the number of civilizations in the Milky Way capable of emitting detectable radio signals. But Drake knew that certain conditions would have to be met. After all, how could a microorganism on a distant planet send us signals without even possessing intelligence? The equation itself is straightforward. Drake considered variables like the number of stars formed annually, the planets orbiting them in the habitable zone, neither too cold nor too hot, the fraction of planets where life could thrive and evolve, and finally, the lifespan of such civilizations. With these factors, the equation intended to address one big question. How many civilizations in our galaxy could be broadcasting signals right now? Since its publication, the Drake equation has sparked endless debate among scientists about the values of its variables. Its simplicity makes it brilliant, but also a constant reminder of how much we still don't know. So what makes this 2024 model so revolutionary? The researchers factored in something the Drake equation didn't: the expansion of the universe and the role of dark energy. This mysterious force, which makes up 2/3 of the total matter in our universe, accelerates its expansion. But here's the catch. For life to form, ordinary matter must clump together to create stars and planets. These stars and planets must remain stable for billions of years to allow life to evolve. This new model calculates the likelihood of intelligent life forming not just in our universe but across hypothetical universes, a scenario known as the multiverse theory. This research doesn't estimate the quantity of intelligent life in our universe. Instead, it calculates the likelihood of an observer existing in a universe with specific characteristics. And here's where it gets interesting. The researchers found that a typical observer in another universe would likely experience more dark matter than we do. In other words, our universe is statistically unusual. They also discovered that a more efficient universe, one that could convert up to 27% of its ordinary matter into stars, might have better odds of forming life. By comparison, our universe only converts about 23%. More stars mean more chances for life to develop. So, while our universe isn't the best candidate for fostering life, we're proof that the improbable is possible. This branch of science, called computational cosmology, blends theory, physics, programming, and statistics to tackle one of the universe's greatest mysteries, the role of dark matter in shaping the universe. Dr. Daniele Sorini from Durham University explains that understanding the parameters governing our universe, such as dark matter density, could even help us understand why we exist. A profound thought, isn't it? And here's the kicker. While a universe with more dark matter might have more stars and better odds of forming life, our existence proves that life can thrive against the odds. So, as we gaze into the night sky and wonder who or what might be out there, one thing is clear. We're part of something extraordinary, even in a universe that's anything but ordinary.
Look at these bizarre bright patches on the surface of Ceres, a dwarf planet in the main asteroid belt between the orbits of Jupiter and Mars. Scientists have been wondering about the origin of these spots for a long time, and the mystery is finally solved. But first thing first, we must speak about NASA's Dawn mission. It was launched to give us up-close views of two celestial bodies, giant asteroid Vesta and dwarf planet Ceres. This spacecraft uses special ion engines, not regular chemical ones. They produce less power but can run for a long time, which makes Dawn faster over time without needing as much fuel. In 4 days, the engines can increase speed by about 60 miles per hour. By the time Dawn wrapped up its mission in October 2018, it was flying a mere 22 miles above the surface of Ceres, practically hugging the planet. Thanks to that, we got a few incredibly sharp images of these mysterious bright spots on Ceres. Even before Dawn arrived in 2015, telescopes had already spotted those shiny patches, but no one knew what they were. From orbit, Dawn snapped high-resolution images of those reflective areas, especially two bright ones inside Ocketer crater. After a lot of detective work, scientists figured out that those areas were mostly made up of sodium carbonate, a compound made of sodium, carbon, and oxygen. In other words, salt. But it wasn't just any old salt. It likely came from the liquid that had risen up from within Ceres and evaporated, leaving behind a shiny salt crust. And that's where things get exciting. Dawn got closer and closer to Ceres, which allowed astronomers to figure out that the liquid responsible for the bright patches came from an underground reservoir of brine or salty water. This briny reservoir is massive, stretching about 25 miles deep and hundreds of miles wide. And since Ceres isn't like icy moons orbiting big planets, where gravitational pull causes internal heating, it manages to keep liquid deep beneath its surface all by itself. One of the most intriguing areas of Ceres is Ocketer crater, a massive 57-mile wide depression that houses the brightest spots on the planet. This crater became one of the main goals of Dawn's extended mission. The spacecraft not only confirmed that these bright regions were young, some less than 2 million years old, but also found evidence that the geologic activity behind those spots could still be ongoing. The thing is, Dawn detected salt compounds in those bright areas, including sodium chloride, chemically bound with water and ammonium chloride. Now, salts with water in them tend to dehydrate really fast on the surface in just a few hundred years. But the salts on Ceres still had water in them, so the liquids must have reached the surface very recently. This discovery is proof that liquid is still flowing from deep inside Ceres up to the surface today. But how does this salty liquid make its way to the surface? Researchers have found two main ways it can happen. When the impact that formed Ocketer crater occurred about 20 million years ago, it melted a layer just beneath the surface. That slushy layer held a bunch of salts that gradually bubbled up to the surface. The impact heat subsided a few million years later, but large fractures left behind allowed briny liquids to continue seeping up to the surface from the deep underground reservoir. So even though the heat was long gone, the crater remained active because of those giant cracks. But Dawn didn't just find evidence of recent liquid activity through these bright patches. It also discovered something that looks a lot like Pingo's small, conical hills found in Earth's polar regions, formed by pressurized groundwater pushing up and freezing. Before, scientists have also seen Pingos on Mars, but spotting them on Ceres was a first for a dwarf planet. This is another clue that there's still liquid moving around under Ceres' surface. It means that Ceres is way more active than we thought. There's salty water beneath the surface and geologic activity that's most likely still happening. The mysterious bright spots, which are the result of liquid making its way up through fractures in the surface. And let's not forget about potential pingos. It's clear that Ceres, even though it's just a dwarf planet, is a dynamic world, much like the icy moons we see elsewhere in the solar system.
Can a planet be bigger than its parent star? Well, if you mean a star like our sun, it's highly unlikely. But what if it was a white dwarf, the remnant of a star similar to ours that went out after shedding its outer layers and leaving behind nothing but the core? This core is what we call a white dwarf. Usually, it's around the size of our home planet. If a star had a planet bigger than Earth before it extinguished, it's possible that such a planet could survive all the chaos. In this case, a planet that is bigger than its star might actually exist. And we've even found planetary systems like this. But there's one problem. A white dwarf isn't a real star like our sun anymore. It doesn't produce energy, just sits out there getting cooler and cooler. So probably such systems don't count. For comparison, the sun is working non-stop. It is fusing hydrogen into helium in its core. It has been doing it for more than 4 billion years and is going to keep doing it for the next 7 or 8 billion years. The sun is 10 times as wide as the largest planet in our solar system, gas giant Jupiter. And sadly, you can't get a planet much larger than that. If you start adding mass to such a world, it will get smaller, not bigger. So it seems you can find a planet larger than the sun. But there are also dim red dwarf stars. They're the smallest out there, barely massive enough to maintain fusion in their cores. The tiniest stars that we know about have been discovered recently. If astronomers' conclusions are correct, then both of them can hardly fuse hydrogen into helium. And it takes about 0.077 times the sun's mass, or 75 masses of Jupiter, to be able to do that. And still, they're real stars, just very tiny, smaller than Jupiter. One of them is only about the size of Saturn, which must mean that stars can have planets bigger than they are, right? Well, theoretically. When it comes to practice, you can hardly find such planetary systems. We've found and observed quite a lot of exoplanets, which are worlds orbiting other stars. It seems that there are indeed loads of trends out there in space, different masses, sizes, brightness, and so on. But the main trend? Red dwarfs don't usually have gas giants orbiting them. If they do have planets, those are typically small, rocky worlds, more like Earth. Those are also called terrestrial planets. For example, a red dwarf called TRAPPIST-1 has 7 Earth-sized planets orbiting it. But gas giants circling around red dwarfs are extremely rare. Hardly 1 in 100 tiny stars can boast such a planet. This number can be even smaller since the research has been done using candidate planets which haven't been confirmed yet. Plus, the smallest stars are also the dimmest. It means they are extremely hard to detect, and it's incredibly hard to figure out whether they have planets orbiting them, and if they do, whether these planets are gas giants or terrestrial worlds. Still, it's possible that a system where the planet is larger than its parent star exists. But the probability is statistically very low. At the same time, red dwarf stars are very numerous. They're actually the most common kind of star in the galaxy, making up around 70% of all stars. And even though really tiny red dwarfs are relatively rare, there still must be millions or probably even billions of them in the galaxy. And if there's even a small fraction of red dwarfs with gas giants orbiting them, it might still mean that a lot of such systems exist in total, and some of them can have planets bigger than their host star. Look at the sky. You can choose any direction, and still, the limits of what you can see extend to astronomical distances. The most ancient light we can observe was emitted a mind-boggling 13.8 billion years ago. This date corresponds to the Big Bang itself. That's why the following fact may sound so confusing. When, after traveling through the expanding universe, light arrives on Earth, it provides us with information about objects currently located around 46.1 billion light-years away. It's only possible because of the expanding fabric of space. That's how the most ancient light we can see corresponds to distances much greater than 13.8 billion light-years. With time, we'll be able to see even farther away since light that's still on its way will finally reach us. And still, at any given time, there will be a limit to how far we can see. That's the limit to the observable universe. It also means that at any point in the past, the universe had a finite size too, and it was smaller than today, depending on how much time had passed since the Big Bang. Okay, but what would we see if we went all the way back to the beginning? To the moment of the Big Bang? Surprisingly, it wouldn't be a singularity, with the universe having infinite density and temperature at a barely perceptible size. No, there would be a limit, and it would be the smallest size the universe could have had. Let's find out together why such a limit must exist and how tiny the early universe could actually be. If you want to know anything about what our universe will do in the future, or did in the past, you need to figure out the rules and laws it follows. And all of them are set forth by the theory of general relativity, which claims that what we perceive as the force of gravity comes from the curvature of space and time. One more thing to remember is that the universe is both isotropic, having the same properties in all directions we look, and homogeneous, having the same properties in all places we could go to. But if the universe has the same properties in all places and all directions, it means that it must either expand or contract. Let's say you know its expansion rate at the moment. Then you can determine the size of the observable universe at any moment of the past or future, its expansion rate at any point in the past or future, and how energetically important each component of the universe was or will be in the past or future. And by these components, we mean radiation, normal matter, dark matter, neutrinos, dark energy, and so on. To figure out what our universe did in the past, or will do in the future, we need to understand how every component evolves with time and when and under what circumstances these components transform into one another. According to the theory of cosmic inflation, the universe was once filled with large amounts of energy. It was similar to dark energy, but much greater in magnitude. It made the universe expand faster and faster. As a result, the universe was getting colder and emptier. And then, after growing this way for a very long, possibly infinite amount of time, most of this energy got converted into matter and radiation, which triggered the Big Bang. Now, about the size of the universe. Today, 13.8 billion years after the Big Bang, the universe is 46.1 billion light-years across. When matter started to dominate radiation, which happened when the universe was around 10,000 years old, the size of the universe was about 10 million light-years. When the universe was 3 years old, it was roughly the size of the Milky Way galaxy. When the universe was just 1 year old, it was both smaller than our home galaxy and unbelievably hot, hot enough to start nuclear fusion. And when the universe was a mere 1 second old, it was too hot for nuclear fusion to occur. Its radius was just 10 light-years, which is still enough to enclose 9 nearest star systems we know about. And if we somehow managed to observe the universe when it was just a trillionth of a second old, we'd see that it was the size of Earth's orbit around the sun.
Stars are beautiful, colorful things. There are red giants. Those are nearing the end of their lives and are on the verge of explosions. Blue stars shine in the belt of the constellation Orion, as well as other places. Yellow ones, like our sun, are pretty ordinary. They're usually warm and stable enough to support life. But look at the night sky attentively. Do you see any green or purple stars? Nope. They're kinda invisible because of the way we humans perceive visible light. The color of a star mostly depends on its surface temperature. The hotter it is, the shorter wavelengths the light it emits will have. The hottest stars are blue or white blue. Those are some of the shortest wavelengths of light. Cooler stars are normally red and red-brown, which are longer wavelengths. At the same time, stars never send out their light in just one wavelength. It's more of a range of light. The wavelengths of light from a star peak in just one color in a bell-shaped curve. But the star emits other colors too. Human eyes have evolved to see yellow and green radiation, probably because our sun emits it mainly in these wavelengths. But a green star emits radiation right in the center of the visible light spectrum, in all possible colors. That's why such stars appear white, which is a combination of all hues. Actually, our sun emits quite a lot of green light, but we perceive it as white. Purple stars, though, are something our eyes won't ever see because they're sensitive to blue light. And since stars emitting purple light send out a lot of blue light too, because these shades are next to each other on the visible light spectrum. The human eye picks up only the blue light. When it comes to other objects in the solar system, many planets seem to have no obvious hue. Look at Venus, Saturn, or Jupiter. They look kinda bland, probably whitish at best, but there are several planets that boast very decisive colors. For example, Mars looks orange-red, Neptune is blue, and Uranus has a beautiful blue-green hue. The planet gets it from all that methane gas in its atmosphere. Meteors sometimes display a vivid green too, and look at breathtaking bright auroras. Green is the most common color of the northern lights. But not stars, never stars. The brightest star in the sky, besides our sun of course, is Sirius. It's twice as bright as its competitor, Canopus, located in the southern constellation Carina. Being the most brilliant, Sirius is very easy to identify. Probably the coolest thing about this star is that it seems to be changing its color. But we'll get to it a bit later. This star is whiter and hotter than the sun. Its surface temperature is 17,300 degrees F, while the sun's surface temperature only reaches 10,000 degrees F. When you combine the immense heat Sirius emits with its girth, 1.75 times the size of the sun, you'll understand why the star looks so bright in the night sky. Sirius has a companion star. It's called the Pup. It's a tiny but incredibly dense white dwarf with a diameter of a mere 7,000 miles. This makes it smaller than Earth. At the same time, its mass reaches 98% of that of the Sun. It means that the matter inside this tiny star is squeezed very, very tightly. That's why its gravitational pull is 350,000 times greater than Earth's. A person weighing 150 pounds would weigh 50 million pounds on this star. Now, Sirius is famous for its twinkling, and since it is also the brightest star, we can observe the ever-present turbulence in its atmosphere quite well. As for the star changing its color, it has to do with the atmosphere of our planet. Pockets of air at different temperatures focus starlight this way and that like small lenses. We see it as twinkling. But since white light is made of different colors, one pocket might send some red our way. Another will send blue or yellow in totally random order. That's why it seems that Sirius twinkles in color.
Most of those twinkling dots scattered across the night sky seem unreachable. But one of them is Betelgeuse, a star so enormous and nearby that you can see it with the naked eye. To find it, locate the first 3 big dots in the Orion's belt. A reddish star to the left is Betelgeuse. It's one of the brightest stars we can see from Earth, and it's just 640 light-years away. No big deal. Betelgeuse has a blue-white O-type star, which is one of the hottest types to exist. Betelgeuse was scorching hot, reaching temperatures of about 90,000 degrees Fahrenheit. Although that was back in the day, now it's an elderly star, and it cooled down to just 5,800 degrees. You know, vacation weather. Blue-white stars are absolutely massive and burn incredibly bright because they have loads of hydrogen fuel. But they have a price to pay for this glory. They burn through their fuel super quickly. As they age, they transform into red giants. This is exactly what happened to Betelgeuse. It burned through its hydrogen and started burning helium instead. This caused its outer layers to puff up like a balloon, turning it into a red supergiant and making it one of the largest stars out there. Now it's stretching over 700 million miles in diameter. Now it's about 1,000 times bigger than our Sun. If Betelgeuse replaced it, it would swallow up Mercury, Venus, Earth, Mars, even Jupiter. And its atmosphere would almost reach Saturn. But something strange has been going on. Betelgeuse spinning way faster than it should for a star of its size. Huge stars like Betelgeuse are expected to rotate slowly, but it suddenly started spinning at a rate of about 3 miles per second. Thanks to powerful radio telescopes, Betelgeuse's orange-red surface can be seen in detail. That's how we learned that it often changes its brightness. Sometimes Betelgeuse shines super brightly and then gets very dim. This happens about every 400 days. And recently, a telescope called ALMA, which is made up of many antennas working together as one, showed that Betelgeuse's surface seems to be moving unevenly. It's like one side is coming towards us while the other is moving away. But all of it might be a trick of light. Betelgeuse isn't as smooth as our sun. Instead, it's super chunky. Its surface is like a boiling cauldron. It's bubbling and churning incredibly fiercely. Imagine giant plumes of hot gas erupting from its core, reaching the surface and then vanishing back inside. And these bubbles are bigger not only than the Sun, but Earth's entire orbit around the Sun. These bubbles also rise and fall super quickly, even faster than a spacecraft. And maybe this tricks our telescopes into seeing it spin faster than it really does. Some astronomers also think that Betelgeuse could have swallowed up another star, and this gave it a spin boost. But these are all just theories. Things got even more complicated when Betelgeuse dimmed once again, this time in a pretty unexpected way. What's interesting, it was discovered using a weather satellite. A regular telescope had a hard time seeing Betelgeuse clearly because of Earth's atmosphere. So they used a satellite that normally watches Earth's weather, but can also take pictures of space. As we mentioned, it usually brightens and dims about every 400 days. But recently, it suddenly dimmed by 2.5 times more than ever before. This event got the name the Great Dimming. The first theory said that Betelgeuse cooled down and sneezed out a bunch of material, creating a massive dust cloud. This cloud blocked the view of the star, making it look much fainter than usual. They also noticed something strange happening to that dust. It started behaving differently, which might be a sign that something deep inside the star was causing trouble. Betelgeuse's brightening and dimming cycle now happens faster in just 200 days instead of 400. And to add to the mystery, in the spring of 2023, it started shining even brighter than it normally does at its peak. Why is this frightening? Because Betelgeuse might be preparing for its grand finale, and this wouldn't be very good for Earth. We might be on the verge of a supernova. When massive stars like Betelgeuse run out of fuel in their cores, they start burning different elements like carbon, oxygen, and silicon. Eventually, they end up with iron in their cores. At that moment, everything changes. Adding helium to iron doesn't produce energy like other reactions do. Instead, it sucks up energy. This causes the star's core to collapse, leading to what's called a core collapse supernova. A spectacular, breathtaking show. Supernovas are so bright that they can outshine entire galaxies. But a Betelgeuse supernova would be special. Because it's relatively close to us, it would be so bright that we could see it even during the day. When it happens, Betelgeuse will shine as brightly as a full moon, but all that light will be concentrated in one point. For about 2 months, it will be so bright that you could read a book just from the light of the supernova, even if you turned off all the city lights and had a clear sky. The idea of witnessing Betelgeuse explode as a supernova is truly thrilling. After all, the last time a star went supernova in our galaxy was way back in the time of Johannes Kepler, more than 4 centuries ago. That event, known as the SN 1604 or Kepler supernova, dazzled the sky for weeks. But don't get too excited yet. We're not sure when exactly it'll happen. One study says that the star might be in its carbon-burning phase. If we're near the end of that stage, then Betelgeuse might blow up very soon, during the next tens of years. But it's nearly impossible to determine because during that last phase, the star barely changes at all. Even though Betelgeuse is close enough for us to study its surface, we can't peek inside its core to see what's really happening with it. We might as well be at the beginning of the carbon-burning phase, and in that case, we might have to wait 1,000 more years before that cool supernova. Another study says that Betelgeuse might have less than 300 years of fuel left in its core. They say that Betelgeuse is known to expand and contract regularly, and its pulsation pattern hints that Betelgeuse is much larger than we previously thought. This would suggest that the star is further along in its life cycle and closer to going supernova. Other guesses come from observations of similar stars. For example, a star called VYCMA in our galaxy is thought to be closer to going supernova than Betelgeuse, and it's been dimming steadily over the past century, unlike the relatively stable Betelgeuse. If Betelgeuse was about to go supernova, it would dim steadily and very quickly. Also, historical records suggest that about 2,000 years ago, people saw Betelgeuse as yellow, not red. If that's the case, then we might be in its early last days after all. In other words, we have no idea whether it will go supernova tomorrow or in 1,000 years. We just gotta wait and see. But let's say it goes supernova tomorrow. What happens to us then? The 1987 supernova in the Large Magellanic Cloud showed that the effects from the supernova might be so strong we can sense it even from very far distances. The Large Magellanic Cloud is almost 170,000 light-years away, and we still detected the radiation. It's kinda hard to say exactly what the danger zone is. A rough estimate could be around 100 light-years. Luckily, Betelgeuse won't pose any danger to humans. It's hundreds of light-years away, and its supernova won't influence us in any way. We'll be able to enjoy its supernova beauty without any harm. Chebyshev star was discovered in the 1960s. Since then, astronomers have been intrigued by its unique chemical makeup. The star is suspected to contain ultra-rare elements, verging on the almost impossible. Using special equipment on the European Southern Observatory's telescope in Chile, researchers took readings of the star's magnetic field. They discovered that the star's rotation period, which is the time it takes to finish one revolution on its axis, stretches out over almost 200 years, which is super slow. Of course, there are even more bizarre objects called apstars. They're a chemically interesting category of stars that rotate extremely slowly, with one rotation taking up to 1,000 years. What makes these stars even more peculiar is a wide range of chemical elements astronomers detect when analyzing their stellar spectrums. But if we look at Chebyshev star, we'll see that it's both similar to and different from other apstars. It contains unusually low amounts of iron and nickel. Our Sun has 10 times more and incredibly high amounts of rare, heavy elements. Those might include strontium, cesium, and neodymium, as well as at least 2 undiscovered elements. They wouldn't occur through any natural processes we currently understand. There's a hypothesis that the presence of such heavy elements could be caused by a star's unseen companion, like a neutron star. Some people go as far as to say that such an incredible chemical makeup could be a sign of an alien technosignature. Any specialist will tell you that it's the strangest stellar spectrum they've ever observed. Some even claim that there are so many chemical indicator lines you can't immediately understand what you're looking at while observing the star's spectrum. Chebyshev star also contains high levels of radioactive elements that take a few thousand years to decay. And here's where another mystery lies. They should have long vanished from the star. After all, it's almost 1.5 billion years old. Scientists haven't managed to figure out the reason for the presence of these elements yet. Maybe it's the combination of the star's rare qualities. It spins very slowly, it's hot, and it has a strong magnetic field. This could raise to the surface atoms that would normally be mixed inside the star. There's another theory that explains the presence of these radioactive elements. They could be there as if they were themselves decayed forms of ultra-heavy elements that we haven't discovered yet. So far, no one has been able to prove this theory. Even the discovery of Chebyshev star's super slow rotation doesn't bring us closer to the answer. It's obvious that there's a lot to learn about the bizarre star, and who knows which secret it still has up its sleeve. Another not less mysterious star is called Tabby's star. It's a sun-like orb around 1,500 light-years away from Earth, sitting in Cygnus the Swan. Unlike our Sun, this star dims randomly by 5 to 22%, and it lasts for days at a time. The reason could be a giant planet passing in front of the star, but then the eclipses would be more regular and not so random. And if it was a Jupiter-sized planet, it would also need to block around 1% of the star's light, which would make it unique and unlike anything we know. After American astronomer Tabitha Boyajian discovered the star's massive and irregular fluctuations in 2015, further observations followed. They show that the overall magnitude of the star has been gradually dimming over the years. Some theories trying to explain this phenomenon are quite believable. For example, some scientists think that these brightness changes are intrinsic to the star. They could be caused by its magnetism or changes in heat flow in its interior. Other ideas are more daring, including some kinds of activity of an extraterrestrial civilization. One of the most plausible theories, though, is that the dimming is caused by the chunks of an orphaned exomoon. It could have been pulled away from its parent planet by gravitational interactions with Tabby's star. As the moon approached the star, it exploded, sending dust clouds into stellar orbit. These countless chunks of rock and dust are now moving between Tabby's star and Earth in a giant, clumpy cloud. It could indeed explain why we observe such irregular brightness variations. Usually, when astronomers spot a spiral arm structure, it turns out to be a galaxy. But not in this case. SAO 206462, located 460 light-years away from our home planet, is a young star. It's surrounded by a circular disk of gas and clearly defined spiral arms. The bizarre star was spotted during an exoplanet search with the help of the Subaru telescope located in Hawaii. Instead of finding fully fledged planets around a young star, astronomers discovered planets that were still in formation. These baby planets are growing out of the disk of gas and dust surrounding the star. The disk extends out to around 80 astronomical units, which is twice the orbit of Pluto. At least 2 of these planets have stretched the disk into its extremely unusual spiral shape. A different planet is responsible for each arm. In our home galaxy, there's a giant star that is a real stellar wind machine. At the moment, this monster is just waiting to burst and send a wave of radiation and hot gas towards Earth. All because it's a Wolf-Rayet, a star which is at that precarious point before it goes supernova. Its core doesn't have any more helium left to burn. Instead, the star is forced to churn through much heavier elements, for example, oxygen. Unfortunately, it disrupts the careful balance between gravity and fusion, leading to the star shedding its layers. When the oxygen eventually runs out, the star will go supernova, but this time the show will be different. The thing is, WR104 is 1/2 of a binary pair, which means that 2 stars are feeding into each other, spinning up their stellar winds. It will continue until they start going incredibly fast. Is the potential explosion going to harm Earth? On the one hand, we're far away enough for even a directed supernova to not hurt our planet. At the same time, there's a threat of an extremely dangerous gamma-ray burst. Luckily for us, it takes a very specific and unlikely train of events for a Wolf-Rayet to produce a gamma-ray burst. Plus, even if it does, the star might be pointed far away enough for the danger to miss us. Anyway, astronomers are still watching the star, just in case. A star sitting in the constellation of Centaurus keeps a secret not many know about. At first glance, it looks like a dim white dwarf, but when astronomers analyzed it, it turns out to be incredibly dense. Take the mass of the Sun and cram it into something that is only 1/3 the diameter of Earth. This space wonder is also rather cool. Its core temperature is a mere 11,900 degrees Fahrenheit. For comparison, the Sun's core temperature is around 27 million degrees Fahrenheit. At such low temperatures, stars begin to vibrate. And then, scientists can use these vibrations to sneak a peek inside a star. And in the case with the star in question, which was later named Lucy, they discovered that its carbon core had crystallized. In other words, it formed a giant diamond 10 billion trillion carats in size. Since the discovery of Lucy, a few other crystallized stars have been spotted. Some of them have diamond hearts the size of our planet. The last bizarre star for today is called Vega, and it's squashed. The star's bulging waistline is caused by an extremely high spin rate. Vega rotates once every 12.5 hours. This pushes the material around its equator outward. It also leads to the phenomenon known as gravity darkening, when stellar material further from the center of the star experiences less gravity, which makes it cooler and darker. So when Vega faces Earth pole end on, it looks perfectly round. But the dark halo around its middle is a telltale sign of Vega's oblate shape.
Spotted. It seems like two giant stars were caught in the middle of a romantic kiss. This sounds a little bit like paparazzi fodder at first, but we're actually talking about a cosmic twist an international team of astronomers has discovered. So, the life cycle of a solo star is relatively simple. They're born in vast, gassy areas of space, burn through their fuel, and at some moment, they explode as supernovae. But when stars are born relatively close to each other, their gravitational pull can cause them some troubles and captivate them into what seems like an eternal dance. In some moments, they come so close to each other that they're practically touching. These stars may spend billions of years circling each other, but their kiss lasts for a few million years only, which is just a blink of an eye in cosmic terms. The lead author of this study was on a mission to find these binary stars caught in such a cosmic kiss. He focused his search on the Tarantula Nebula, a beautiful star-forming region located in a large Magellanic Cloud, which is 160,000 light-years away from our home planet. And there it was, the shiny double star system that stood out from the rest. The two stars found there were pretty big and nearly the same size. Together, they make a mass of about 57 times larger than that of our Sun. Before this, we discovered only 3 other binary systems with a large mass. And since these two stars were so close to each other, they created an intense gravitational pull. This made them orbit each other at a staggering rate of once a day, with their centers a mere 7.4 miles apart. With the stars being so close, they formed a bridge where their fuel could mingle, allowing for around 30% of their total volume to be shared between the two. Temperatures of this system were crazy too. At first, it seems the internal mixing of their energy might make these stars live longer, as it allows for more fuel to be burned and for longer periods of time. But this is just a temporary benefit. There are 2 most likely scenarios for the star's ultimate fate. They could merge to form one giant star, which would eventually explode into a supernova. Or they could each explode separately and live out their remaining years as black holes orbiting each other. If they merge, this process would probably take around 600,000 years, while if they become binary black holes, they could continue burning for another 3 million years. But both scenarios would ultimately lead to their destruction. Unless the stars could end up as 2 separate black holes drifting away from each other through the vastness of space, there's a possibility for that to happen too. There's something spectacular stargazers across the globe could see recently. Jupiter and Venus, the 2 brightest planets in the sky, ended up so close it appeared like they were about to collide, or as if they were kissing too. At least that's what it looked like from here on Earth. In real terms, they're still 400 million miles away from each other. Here's another interesting thing astronomers like to talk about: G-objects. Those are celestial objects that look like clouds of dust and gas, but behave like stars. At the center of our galaxy, there's a supermassive black hole. It's 4 million times the mass of our Sun, and recently, scientists found out there are 2 mysterious G-objects that hang out pretty close to that black hole, so-called G1 and G2. And the most probable theory is that G2 are two stars that were orbiting the black hole in tandem and merged into an extremely large star cloaked in unusually thick gas and dust. During G2's closest approach to the black hole, it showed a strange signature. It was elongated, and much of its gas was torn apart. As it got closer to the black hole, it lost its outer shell, and now it's getting more compact again. The thing that has everyone excited about the G objects is the material that gets pulled off of them by tidal forces as they sweep by the central black hole. This material must inevitably fall into the black hole, and the result is an impressive fireworks show. This happens because the material eaten by the black hole will heat up and emit radiation before it disappears across the event horizon. An event horizon is that scary boundary around a black hole from which nothing can escape. Now, it seems scientists have discovered 4 more G objects, and they're all located within 0.13 light-years of this black hole. And it could be that all of the 6 objects used to be binary stars that got together and merged because of the powerful gravity of this giant black hole. Usually, it takes over 1 million years to finish the merging process between 2 stars. We definitely want more G objects because it's one of the rare opportunities for us to study how things behave near a supermassive black hole without being swallowed. Yet. Have you heard of variable stars? Look up at the sky. We often think of the stars as unchanging, eternal lights. Yes, some stars might appear constant, but others change in brightness over time, which is why we call them variable stars. Some of them dim and brighten again over days, months, or even years. We can't see it with the naked eye. We're talking about changes astronomers can only notice using equipment and over longer periods. And how about vampire stars? Imagine 2 stars, a red giant and a white dwarf, in a binary system, swirling around each other like cosmic ballet dancers. The red giant, which used to be a vibrant and fiery star, now has aged and grown tired. Its outer layers of hydrogen, which were once held tightly by its gravity, have now weakened, making it vulnerable to the smaller, denser white dwarf. The white dwarf, known as the vampire star, thirsts for the hydrogen fuel that its larger sibling holds, and it sees a great chance there. As they spin together, the vampire star uses its powerful gravitational force to steal the hydrogen from the red giant's outer layers. The vampire star glows with a blue hue, looking full of energy and more youthful and vibrant than its aged dancing partner. Not only vampire stars, the horror continues with zombie stars too. Sometimes when the red giant explodes, it doesn't completely break up into smaller pieces. Instead, a white dwarf remnant is left behind. It's basically a zombie star that was gone at the moment, but has risen back to life. But this isn't your average zombie, hungry for brains. No, this star hungers for the very substance that its vampire sibling had been taking from it all along, hydrogen. And if the zombie star is close enough to its victim, it will start sucking material back in to start its core again. It will become a hydrogen explosive, ready to go boom in a spectacular show of cosmic revenge. It's a fascinating phenomenon. We usually won't even manage to detect it because these explosions are much fainter than the usual supernovas. But when it does happen, the resulting blast is truly epic. And it destroys both the vampire star and its zombie sibling. It seems vampires and zombies may not be a work of fiction after all. Not only are we made of stardust, but we're also more similar to stars than we thought too. For example, stars also like to hang out with their close group of friends. Most stars prefer to travel through the universe in clusters. It's a group of stars that end up bound together by gravitational force. The stars in the cluster are mostly made of the same age and type, hobbies, and interests. I guess even they have better social lives than I do. what would the Earth look like if it was born in another solar system? I did a little research for you to find out, and the results were surprisingly wholesome. There are some warm tropics, strong winds, and giant dragonflies. But okay, let me explain from the very beginning. Since 1995, NASA has discovered more than 4,100 planets outside the solar system. Unfortunately, most of them are either flying ice balls like Neptune or gas giants like Jupiter. But there are still as many as 161 planets similar to our Earth. And one of them is very close to us, in the Alpha Centauri constellation. There are 3 stars in this constellation. 2 of them are called Alpha Centauri A and Alpha Centauri B. If you live in the southern hemisphere, you've probably seen them. They're very bright. Because of that, they look like one big star. They rotate around each other very slowly. And there's the 3rd star, chilling around not far from them. It's a teeny tiny red dwarf, Proxima Centauri. It got its name because of its proximity to our Sun. This star is the most interesting one, so let's talk more about it. Proxima Centauri is only 4.5 light years away from us. Oh, and 1 light year is about 6 trillion miles. Yep. If we went there, it would have taken just a little over 165,000 years of traveling in a space shuttle. Oh, you think that's a lot? For the universe, it's like checking on your fridge. Proxima Centauri is much lighter and much smaller than the Sun. It's also 2 times colder than the Sun, with a temperature of 3,000 Kelvin. That's why we can't see it without a telescope. On the bright side though, it will burn for trillions of years, and you don't have to worry that one day it will eat us like our Sun. And yes, our twin planet is located right next to Proxima Centauri. This planet is called Proxima b. Yeah, I know, they got creative with all these names. I hope you won't get confused. It's slightly larger and more massive than the Earth. This planet is located in the habitable zone of Proxima Centauri. It means that there can be water and even some microorganisms there. Yes, it's possible that one day we'll find some life there. But right now, we don't know much about this mysterious planet. It's probably a rocky planet like our Earth and has a similar landscape, but this is just a theory. Who knows what kind of jokes the universe can throw at us? It would be a shame to fly 165,000 years just to stumble upon a giant piece of ice or something. Fortunately, we probably don't have to wait that long. The big brains are now developing a technology that would allow us to move at the speed close to the speed of light. If they succeed, we'll get to Proxima b in just 20 years. But anyway, this video is not just about Proxima b. It's about what would have happened if life had originated not in our solar system, but in Alpha Centauri. What if we were orbiting Proxima Centauri, or the other 2 stars? So now, let's imagine that the Earth has replaced Proxima b. I'm going to call this new planet New Earth. Guess I'm not very creative at naming either. First of all, the orbit. The new Earth must be about 25 times closer to its star than Proxima b is. Otherwise, it would be unimaginably cold. Let's move the planet a little closer. Excellent. The day still lasts 24 hours, but our orbital period is very high. Proxima b revolves around its star in 11 days. But we'll make it in just 8. Hey, a birthday party every week? Sign me up. Oh, hold on, there's another problem. You see, Proxima Centauri is a flare star. This means that sometimes, just out of nowhere, it throws out some stellar winds. These winds carry around a bunch of ionized particles, which then settle on the planets. Yeah, our Sun also does that, but Proxima Centauri tries to finish us off 2,000 times harder than our Sun, so the radiation levels are off the scale, to say the least. Don't worry, it's fine. All we need are incredibly strong magnetic fields. They will help us create a very thick atmosphere that can protect us from the Proxima Centauri's tantrums. So now it's going to be very warm, or not. Another problem. Scientists are still not sure how exactly Proxima Centauri's planets rotate around it. what if they turn out to be tidally locked, like our moon? Then one half of the new Earth will be a frying pan, and the other half will be some frosty deserts. Oh, it's fine, we'll just settle down somewhere in the middle. Didn't expect that I would ever say this, but it will definitely be warm at the North Pole. And if we're lucky with the rotation, we'll just get a cozy, warm planet. The average temperature is about 70 degrees Fahrenheit, and there aren't any extreme temperatures. On the new Earth, we have much more water. The weather is generally pretty crazy, some very strong winds and quite destructive rains that can go on for quite a long time, but you can adapt. Temperature changes are much more noticeable in the mountains. Just like on Earth, the higher you climb, the colder it gets, except it's very cold right here at the top. Because of this, the mountains and hills have jungles below and snow-covered deserts on the tops. But in general, it's almost like the Earth's tropics. The flora is very rich, the trees are very low but lush. The thick atmosphere also makes flying easier, so there are a lot of large flying animals, like dragonflies with a wingspan of 16 feet. Moving on. The sky here is much lighter than that on Earth and very cloudy. Sometimes it may seem completely white. But the starry night is beautiful and bright. There are 4 suns. Our main one is Proxima Centauri. We can also see 2 bright Alpha Centauri stars. And finally, our old sun, which looks like a bright, distant star. I'll allow you to shed a tear for the old Earth. There's a few planets near us, like Proxima Centauri c. The host star is surrounded by 2 belts of cosmic dust, so get ready for some gorgeous, colorful night views. So what we have in the end is a little crazy, but a beautiful green planet. I personally wouldn't mind moving there already. What about you? Write in the comments. Alright, so now we know what would have happened if our Earth had been born near Proxima Centauri. What about the other 2 stars? Unfortunately, we won't be able to rotate near 2 stars at the same time. Scientists suspect that Alpha Centauri A and B have some kind of common planet that jumps from one orbit to another, but it's probably very cold. Let's choose Alpha Centauri A. Just like on the new Earth, here our average temperatures are about 70 degrees Fahrenheit, but now the temperature variation is quite large. It goes from negative 100 degrees Fahrenheit at the South Pole to 113 degrees Fahrenheit at the equator. We'll be fine close to the north. The day is still 24 hours, and the orbital period is 1 year and 1 month. It's almost the same for the Alpha Centauri B, but the orbital period is about half a year. Other conditions are very similar to those on Earth. Changes in the seasons are almost not noticeable. The temperatures don't change much either. No matter where we settle down, the neighboring star will be clearly visible, but we probably won't see Proxima Centauri. And that's about it. Of course, all this assumes perfect conditions. Just like on Earth, one slightest change, whether it's a thin atmosphere or a bigger distance from the star, and it won't end well. We got really lucky with our Earth. But even so, the chances of finding a habitable planet are very high. Even with the tiniest possibility, there will be about 15 million planets in our universe that we can find life on.
Arcturus, a huge red star. It's just bursting from inside out. The red sea of plasma on its surface rages and pulsates. The star burns anything that comes close to it. And now, plop! Arcturus is gone. But at the same moment, it reappears at the center of our solar system, replacing the sun. What we see in the sky isn't a small yellow dot anymore, but a giant red ball. It's 25 times wider and 30% heavier than the sun. Even though Arcturus is a little cooler, it's still a total nightmare for Earth. The distance from our planet to the star is now 25 times less. All the water in the oceans and rivers begins to evaporate. What used to be rainforests are quickly turning into a lifeless desert. But sunsets and sunrises now look amazing. Imagine yourself on the roof of the Empire State Building, watching the sunrise. First, You see the light over the horizon. It almost blinds you because Arcturus is 110 times brighter than the sun. Then, the star gradually climbs over the surface. The thick dot on the horizon gets wider and wider. It continues to grow until the red star is everything you can see. Arcturus is now so close that you can even see storms of hot plasma on its surface. There are periodic outbursts and mass ejections. Huge amounts of matter are ejected from the surface of the star at speeds of up to 1,200 miles per second. The matter takes the form of a loop attached to the star at both ends. And you have to wear a super advanced spacesuit to be able to observe such a sunrise. Life on Earth ceased to exist long ago under these conditions, and it's going to get worse over time because every 8 days, Arcturus's brilliance increases, and soon our planet will become more like Venus. It's so close to the sun that the high temperature makes any life there impossible. Okay, let's let our planet cool down a bit and put Proxima Centauri in the center of our solar system. It's not a red giant, but a red dwarf. This star is almost 7 times smaller than the sun and almost 9 times lighter. Now our oceans and rivers are not evaporating, but freezing over. Forests and jungles are covered with snow. In about a week, there won't be a single place on Earth where the temperature is above freezing. Even plants that are used to the cold will cease to exist. They mostly feed on the sun's energy. Now, they begin to starve. But there will still be water deep beneath the ice layer. It'll be heated by the hot core of our planet. Microorganisms will still be able to survive. It's much darker on Earth too. It's like an endless twilight here. Oh, and we can barely see the moon. The thing is, it doesn't produce its own light, but reflects it from the bright sun. With Proxima Centauri instead, the moon will lose its brightness.
Hop on the bright side of life together with our brand new tees, hoodies, and more. Click the link to pick your choice.
But an even bigger problem would be with our orbit. The sun has a certain gravitational force, and it keeps us just in the sweet habitable zone, where we're not too hot and not too cold. Proxima Centauri's gravity is much weaker, and Earth is slowly drifting away from the star. We now run the risk of encountering asteroids flying through space, or even other planets. But the worst-case scenario is if Proxima Centauri simply can't hold our planet, and we fly away into dark space. Then, you can forget about any forms of life here. Now, let's put Sirius at the center of our solar system. It's the brightest star in our night sky. It's only 70% bigger than the sun, but almost twice as hot. So its glow is not only bright, it's sizzling. And its light is not yellow, but somewhere between blue and white. You couldn't go out in the city without sunglasses, or Sirius glasses. Still, you wouldn't want to walk the streets, where the asphalt is boiling anyway. You could literally fry eggs on the curb. Of course, by this time, all life on Earth has long since disappeared. But it's not just because of the temperature. Sirius emits enormous amounts of radiation. Our atmosphere serves as a shield against the sun. But in the case of Sirius, that shield wouldn't be enough. Now, why don't we take a more bizarre approach and make ourselves a double star system? These are 2 stars that revolve around a common center. And there's our Earth, safe and sound. It's all about the size and brightness of the stars. These 2 aren't too big, and they give off as much light as our sun. All that matters to us is that our planet is in the safe zone of the double star system. At sunrise, you first see one star appear from below the horizon, and then, a couple of minutes later, the other. The only problem is that this beauty may soon explode with enormous force. In binary systems, one star is always heavier than its companion. Sooner or later, it starts pulling matter away from the smaller star. Gradually, the bigger star just eats its neighbor. Then the big brother can reach a critical mass and explode. This explosion would be about as strong as a supernova. It would destroy our entire solar system. The light from this explosion would be visible for hundreds of light years away. And after that, there would be a huge nebula in the place of our star system. It's stardust and particles that are left from our world. Going to the realm of the crazy now, a black hole. Yes, there's one at the center of our solar system now. We know black holes are scary, mysterious objects that pull in everything in their path. But even around a black hole, there is a habitable zone. You just have to be far enough away so that it doesn't drag you down into its black abyss. Mercury and Venus would be too close to the black hole, so most likely they'd be torn apart and then head for the event horizon. This is the last stop before hitting the singularity, the heart of the black hole. There are only two problems: light and time. A black hole pulls light in instead of emitting it, so the Earth will quickly become dark and cold. And time goes slower around heavy objects. Near a black hole, 1 second can be equal to weeks or even months away in outer space. We won't feel this difference, but the entire universe around us will develop faster relative to us. Any object can become a black hole if it's compressed to a certain size. For example, the Sun can become one if it's shrunk to a width of 3.7 miles. And even the Earth, if you squeeze it to a width of 0.7 inches, it becomes a black hole. Oh, now there's some little rock lurking in the center of our solar system. It's a neutron star. It's about 18 miles wide. Some meteorites are much bigger than that, but it has a mass comparable to the Sun, so its gravitational force is about the same, and our planet's orbit is intact. But the problem is that neutron stars emit next to no visible light, so it's now permanent night on Earth. Still, it gets very hot here. When a neutron star is born, it can be several times hotter than the Sun at first, but it quickly cools down to the temperature we're used to. So there's a chance that all life on Earth hasn't yet been scorched. Another problem is that these little guys are rapidly spinning and can become pulsars. It's kind of like a powerful spotlight on two sides of a spinning star. Neutron stars also eject radiation at tremendous speeds. These rays will make our planet literally sterile. No life form would be able to exist under these conditions. And now, it's time for the biggest star ever known, Stephenson 218. This red giant is 2,150 times larger than the Sun, and if we place it at the center of our solar system, its edge will lie on Saturn's orbit. So Mercury, Venus, Earth, Mars, and Jupiter are already swallowed by the huge star. Saturn, Uranus, and Neptune are roasting like chestnuts on a fire and will soon evaporate. In fact, this could happen to our Sun as well. The older it gets, the redder and bigger it becomes. It'll eventually run out of its fuel, hydrogen, and the Sun will start to burn heavier elements in its core. This will cause it to expand. Then we'll see more beautiful sunsets and sunrises, but the temperature will become too high. In theory, the Sun will get so big that it'll swallow the Earth, and then it'll explode in a supernova, leaving nothing of our entire solar system behind.